Okay, let's get started. Maybe we can start with, we have a additional.
The Jung imagery, know this one? Okay.
So maybe we can start with a brief introduction of who we are. My name is Jinha. I'm with the Purdue University School of Civil Engineering, and Qiusheng from University of Tennessee. So we're going to be doing this in a workshop today. Hopefully we can have some fun today. So before we started, I'm going to ask you a question. So how many of you created any type of content, like video, articles? You just, we all do, right?
Not software.
Not software. So let's say that any of you have created any types of video before? Yeah. Where do you upload your video? Then you can
upload the video?
Yeah, upload so that you can share with your colleagues, friends.
Usually like YouTube.
YouTube,
yeah.
Right?
Social media.
Yeah, that's how it's been like in old days. You create some form of content. You just create a file. In old days, you just put into DVD and send the DVD by mail. Then you're going to receive it, copy to your the computer and work with it, right? That's been like this, but these days everything is on the cloud. You can essentially upload everything on the cloud. Now you are not sending your file anymore, right? Video is a good example where YouTube has more than 95% market share in video streaming right now. And you just, whenever you create some form of video content, you don't even think about it. You just upload it because it's free. You just send the link to your friends, then your friend will have a way to actually consume it, right? So basically what I want to do, we're going to have only 3 hours, so we have a short period of time. But Qiusheng will be doing the second half of the workshop. I'll be doing the first half. And the first half, I'm going to be covering something called a data to science. This is an online platform that my research group is developing right now, where you can actually upload your geospatial data to the cloud. Then you can manage it, share it, and do some analysis with it. So that's pretty much the whole idea. So for that one, what we're going to do is that if you click, I believe you can scan this code, you're going to get to this page, or you can just type in this bit.ly FOSS4G D2S. You're going to reach to this one. There is a link here, docs.geospatial.org.
Sir, where's the bit link?
Go up here. FOSS4G, bit.ly, FOSS4G -D2S.
Mm-hmm.
It is case sensitive. So
Yeah, case sensitive, all uppercase.
Yeah.
FOSS4G -D2S. I think I can also send to the
Email.
the app.
Oh yeah, we do have an app. Yeah. So everybody is on this page?
I'm on that page, yeah.
Yeah. If you click this, docs.gds.org, data to science and engine workshop. If you click that, then you're going to get to this page. So basically in the first half, I'm going to go over this tutorial. I'm not going to be looking at this document, step by step. I'll be just, going through this. But for later, if you just need to repeat whatever I did, if you don't remember what it was, all the information should be over here. Okay. So basically, if you click meet the instructor, this is my research group. So me, my postdoc, and then the Ben, both Minyoung and Ben is here. So you will have a chance to meet them later.
just have a copy with them earlier.
Yeah, so here you are. Docker 101. So this is an open source project. So if you want to deploy your own instance on your own server on the cloud, you can actually deploy your own. Exactly what we're doing over here. So we are not going to go over this deployment part, but the one that we're going to go over is this getting started. So what I want to do is by clicking download sample data, this data set is mainly UAV drone imagery. So we just flew the drone imageries, just process this image to generate the orthomosaics, point cloud, detailed surface model, all those kind of different data products. So I want you to download these two files, boundary file and a sample data. and also multi-temporal in a sample data set here as well. So what I'm going to do here is I'm going to download this, and I'm going to go here. Sorry, if I'm going too fast, please let me know. Go to this user manual, getting started in a download sample data.
And then check on the right, download the UAV here.
So I'm gonna click this, download to your computer. So I'm gonna say that FOSS4G NA workshop. I'm gonna save it there. Sample data also, I'm gonna save it there. This file is not small, I mean, at least in a couple of megabytes. So I want you to kind of start this download process now, so that we can work on something else. So you need a chair. You can take this one. But the thing is that we are very tight. What's your name? Sorry.
Damien.
Damien. And your name?
Keegan.
Keegan. Okay, once you have that one going, for example, first one is 188 megabyte, the second one is 228. So I will just let that to be downloaded. Next one that we're going to do is that I'm going to ask you to go create an account on the platform that we're going to do. So the website is called ps2.d2s.org. So this PS2 is not a PlayStation 2. This is funded by Purdue School of Ag, so it means a Plant Science 2.0 initiative. So that's where this PS2 comes from. So if you just type that in, ps2.d2s.org, just press enter. Then let me see. What you're going to see is this landing page. Why this one is not showing this video? Do you all see the same page?
Yeah. Or the welcome to data.
Yeah, welcome to. I'm not sure why. I think I need to log out first. Yeah. So this is what you see, right? Yeah. So this is in a landing page. You can sign in if you have an account. If you don't, click sign up here. Put your name, email, password. Like I said, password must be at least 12 characters. We don't have any kind of special character or anything. But I think that some of the requirements, you cannot use the same character 3 times in a row or something like this. But just go create an account, and I will approve your account, right away. Then you also have to confirm your email. So let me just go back. So your name, email, password. So just click create an account. So I'm seeing you. Steve, I approved your account right now. And Damien, I approve your account. Oh, probably Ben is doing. Rebecca, I approve your account. Colin, I also approve your account. And Tyler as well.
If you go back to that docs page, click down on sample.
And Alexander, you should be good. John, also you should be good.
That's the first link on that.
And Keegan, you should be good as well. And Robert, you should be good. And I'm approving your account, but you also have to confirm your email. because your email is going to be the way for you to reset your password if you forget in the future. One, two, three, 4, 5, 6, 7, 8, 9. Yeah, I think you're good. So you have your account created? Okay. So anybody still need to create an account? All good? Everyone can sign up? Okay. So I'm gonna go ahead and log in because I do already have my account.
So I'm sorry, it's emailing us
So you're gonna
notification, or?
So you're gonna get an email from D2S to confirm your email. So make sure if it's not, you may want to check your spam folder as well.
Well, I got it in my main folder.
Okay.
Ah.
So everybody can log in, okay? Good. So what I'm gonna do next here is that this, probably you're gonna see nothing there because we just created an account. This is my account, so I have access to a lot of data set that has been already uploaded. One of the key features, like I mentioned earlier, from here, you can, upload your own data set, and you can, manage it. So pretty much everywhere you go, you can access this data, whenever you want. You can visualize, all the data set that has been uploaded. Now you can also stream this data set to whatever platform that knows how to consume cloud optimized data format. And we're going to do that demonstration with the QGIS. So we're going to be streaming this geospatial data. The example that you're going to be dealing with is in a few hundred megabyte. I uploaded the example where we have up to gigabyte. I have an example where we have hundreds of gigabyte orthomosaic images uploaded here where you can stream into whatever platform that you want to do. So that's going to be the first half. Second half, Qiusheng is going to come in. He's going to talk about the geemap and lift map and how to consume data set from here to your Python Jupyter notebook. So that's going to be the overall kind of agenda for today. So what I want to do first is that start with the basics. You can go to My Teams. This is the place where you can create a team. So this is essentially team management. Create a team, add the members to the team. Then you can assign specific project to specific team, so that you don't need to manually each member one by one. You can assign a team to a project where all the member within a team will have an access to right away. So here's some example of teams that I created, and maybe I'm not going to create this separate team here because that will kind of mess up something. But just to let you know, for you to create a new team, click this plus button. Then you just give a name of the team. What is the team about, and search by name. For example, if I search by Tyler, this name will show up. Check and I click Edit, select it. Then that will be a way to add that member to the team. So that's my team. Workspace is the place where we can actually manage a project. So this platform is developed with mind that, hey, you're going to be able to upload your own drone data set, geospatial data set. So you need to create a project. Within the project, you can have a multiple flight. And within flight, you can have multiple data product associated with it. That's going to be the structure. So were you able to download all the data set that you got? So if you can check, for me is my desktop. So you should have this 3 file to be downloaded in your local folder. And I want you to unzip sample data for unloading and the additional sample data. So I'm going to just unzip them. In my case, Mac, I just double click. If you just go to the sample data for unload, you have the orthomosaic images, RGB. You have orthomosaic images for the multispectral, point cloud, and the DSM. You should have these 4 files there. For the additional sample data, now you have orthomosaic and DSM in multi-temporal. So we have a June 4th, 23rd. We have a 2 multi-temporal, right? So
Additional sample data.
So the unzip, the downloaded sample data for uploading and the additional sample data. Don't unzip this in a project boundary.
Oh, I already did.
Yeah, I mean, then you can just keep this in the zip file. I'm going to explain what you can do. So what you can do here is now I'm going to wait, give a few minutes so they can just catch up. So everybody was good to go?
I'm personally still downloading the additional.
Oh, really? Okay.
Yeah, it's also downloading still for me.
Yeah. I downloaded the first two. I didn't see the third link. So it's
But do you have a boundary zip file?
Yes.
Yeah, so I'm going to start with that then,
Okay.
while we download. So the way how it works is that first you need to create a project. So in order to create a project, probably in this workspace page, you're not going to see any of this. There is a button at the top left called create. So you're going to click that. And you can just go in and let's say this is the area that I'm interested in, then you just click this button. Then you can just click, 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 and make a polygon. Then this will become the boundary of a project, essentially. Right? So you can do it this way, but we are not going to use it, so I'm going to exit out, click create again. You see that the upload shapefile at the bottom? So you can also upload boundary polygon if you want. So I'm going to click this and go back to your folder where we downloaded the project boundary. Drag and drop.
Sorry, that was from the sample data for uploading?
No, it's a project boundary.zip.
Oh, that one.
Yeah. So that one, it should be only 2 kilobytes. So you should be able to download it right away.
Do we drag that from the zipped?
Yeah, zip file.
Thank you.
Don't decompress it, just leave it there. And click upload one file, then they will actually show this in a boundary on a map automatically.
Yeah, mine is giving me errors.
What kind of error do you get?
Failed to upload.
Which file did you upload?
Project boundary. Let me try a different.
you took this.
Yeah, let me try this.
So don't upload the shapefile, you have to upload the whole zip file because shapefile requires other files.
What is our project boundary, may I ask? Where are we looking?
So this is, we can just zoom out, this is in a field in Indiana.
Oh.
So I'm from Purdue, so this is Purdue Farm where we just have we have a much larger area. We just cropped into small area so that we can,
Corn?
this, I believe is soybean.
No,
Soybeans?
Yeah.
you downloaded it.
No, but that.
So give me a second. Sorry. Minyoung, can you help us? There's somebody who has some problem with? Sorry. Hey, come back. Okay.
I could do it.
So he's having some problem. Can you help him a little bit?
Would it work through another browser?
Yeah, him.
I'm trying to download it. I'm gonna try different browsers. So,
He needs to download as a zip and his keeps opening automatically.
So while he's working on it, you can give a name, whatever you want. So I'm going to say that FOSS4G example project.
yeah.
FOSS4G North America workshop example project. So give it the name and description, and initially this was developed for agriculture application because funding is from College of Agriculture. So we give them an option where you can put planting date and harvest date. You can use this information if you have a project start, project end, if you want to use it that way. Okay. This is an optional, so you don't need to give information there. But you can also click teams. You see all the teams that you have will show up here. In this case, if you don't have any teams created, you have nothing there. I'm not going to assign to any specific team. So I'm going to say no team and click create. Then I'm going to do, I have a lot. So I'm not going to be able to see it, but you should be able to see a new project card has been created. So I just want to make sure that everybody's up to that point. Good. So if you have many projects, you can filter by project name. So if I just do FOSS, then only that project is going to show up. You're going to click this card to get into the project. Okay. Since this is your own project, you are the owner. You have full control. I cannot see it even as an admin if you don't add me as a member of the project. So you see that this is all the information that you provided when you create a project. There is the button called Manage Access. So you can just click this. You can add member one by one. So I just type in Tyler. I'm sorry, just using Tyler name because that's the name I remember. Click him as selected. Then this Tyler has been added as a viewer. So I'm the owner. Viewer, viewer is the one who can only see the data. They cannot edit for any other analysis. If you click this button, it can be bumped up to the manager. So manager has a little bit more role than the viewer. Owner is in the same as my power. It has a full control. Okay. So I'm gonna just leave this as that. Coming back here, deactivate project. This is when you want to delete it. We are not deleting anything as of now because the chances are that I deleted accidentally. You can just bring it back. But if you just deactivate it, we're gonna just ask you, are you sure you're gonna do it? So if you click this in the red button, then it's gonna be deactivated, which I'm not gonna do it. So keep this project. Now, once you create a project, now you can do a flight. So part that I'm gonna do is we download the sample data workspace and create a project. So, this is another one, but this planting data is such, and region is there. Create a button here. Manage project. Add new flight. I'm just trying to find this information. So, sample data for unloading is an actually acquired in 2022, July 25th. Altitude, how high it was flown is 40 meter, 85% overlap side and forward, and the sensor is an RGB and the platform is in a Phantom 4. So we're going to use this information to create a new flight. So coming back here, I'm going to click this and add new flight. Then you can give a name of the flight. So I'm going to say a flight number 1. Okay. The acquisition date. Remember, it was July 25th, 2022. So July, it really doesn't matter which one you use. I'm going to just give this name. 40 meter altitude, 85% side overlap, 85% forward overlap. Sensor, if you click, can have an RGB, multispectral LiDAR, or is there anything else? Or, am I going too fast? Yeah. This is an RGB platform. We have 3 default. If you choose the order, you can type in whatever you want. But this one is flown by DJI Phantom 4. And click pilot. Whoever who's assigned this team will show it over here. Let's say this is flown by me. Then I'm gonna once you click create, then the new flight will be created. So everybody up to this point. Click create. Then now I think a default view is going to be this in a card view. You can also turn it into a table view because whenever we have too many flight, flipping through the card can be cumbersome. So you have also in a table view as well. But this is the one that you're going to see. So by going into edit flight, pretty much the same. You can edit whatever information they provided earlier. This is delete, same as deactivate, and manage data is the part that you're going to go in. So I'm going to click this and manage data. So once you come here, because this is developed for drone. So though I'm not sure how many have you done the drone mapping before. So to give you an idea, you just fly drone. They just take off, collect the data. With take hundreds, thousands of pictures. Do we process those images to generate auto mosaics, surface model, 3-point cloud, etc. So the data collection starts from the raw data, which is original imagery. Then you just process this in imagery to generate the data product, which is also point cloud and DSM. So you can upload the raw data. And for certain group of people that are assigned, we can actually process this raw data in this platform as well. But there are some license issues, so I cannot open up to everybody because we are using in the backend commercial software to do it. But I'm assuming that you guys have a capability to do it. We do have a web ODM presentation later this week. You can use web ODM, Open Drone Map software to do exactly what I'm doing here as well. So if you want to upload the raw data, click this raw data tab and upload raw data. You just drag and drop, put everything in a single G file, just put it here, drag and drop, click upload, then it will be uploaded over there. Okay? But in this case, we don't have any raw data. So you're going to go to the data product. Okay? So this is the part when you just process the data, have the data product. This is the place where you're going to upload. So click upload data product. If you do so, now you have an option where you can choose which data type that you're going to upload. DSM, which is a digital surface model. Point cloud is in a 3D point cloud. Also is an auto mosaic images. If you have any other data product, you can choose other and give a name of it. Now let's start with the DSM. If you go back to this one here, sample data for uploading. I'm hoping that everybody were able to download this data set by now. Okay, get into it. You will see we have a DSM, also multispectral, also RGB, and point cloud. So we're going to start with this DSM over here. So choose DSM. Then you can drag and drop this DSM over here. Or if you can choose, I think a browse file, you can choose that file as well. Okay? Everybody is good so far? Then click upload one file. Then this will upload your file to the server. There is going to be there is going to be multiple things happening. Not only are we uploading it, this is in a regular raster. What we are doing behind it is that we are converting this into cloud optimized GeoTIFF so that we can actually stream this data set to any other platform. So when you're done, you can just click done button. Then you see they also generate the thumbnail, so you can see it as well. Okay. What I'm going to do is that I'm going to upload them more. So let's say choose point cloud. Going back here, you have a point cloud the LiDAR here. Drag and drop. Okay. Click upload one file. Then for this point cloud data, so what is happening in the behind is that once your upload is done, they're going to convert this into cloud optimized point cloud format as well, so they can stream this in the point cloud.
I'm sorry, that was the LAS file?
Yeah, LAS, last file. So Minyoung is here, so if you have any questions, she's going to be able to help you as well. So you spend a lot of time to download it, now you're uploading it again.
So I'm sorry, this is not this is processing it, or this is just...
This is just uploading it, but once you upload it, we are doing further processing so that we can now stream this data.
The DSM ortho and then the LiDAR.
Yes. So we just did the DSM, now we are doing point cloud. So once you're done, click done button. You see this progress bar at the bottom. It means that they're doing this conversion in the background. So now they are done. They're generating preview. This preview image will show up later. So I will keep going. So we just did the DSM. We just did the DSM and the point cloud. Next one is ortho.
Yes.
Okay. Then I'm going to choose RGB also over here. or let's skip this in RGB because this is in a pretty large file. So I'm gonna do multispectral also. Okay. So let me just drag and drop here, and click upload one file.
This is the first time. It doesn't work. I cannot change the option.
Can you just try to refresh it?
Refresh.
Yeah, refresh the page.
Oh.
Yeah, yeah.
Use the notebook, I just fixed it.
Yeah.
Something went wrong, so
Okay.
it was not able to load
Yeah.
the image from
Yeah.
the
So, by the way, what I did was I didn't go back to the main page before I uploaded the LAS file. I don't know if that makes a difference.
No, I mean, it should not. Yeah. Yeah.
I don't know if that's the reason
Yeah.
why I did that.
So once you do this, now you should have these 3 data product available for here.
I'm sorry, what was the third one? Ortho?
Yeah. Okay. And what I want to do next here is if you go back to your, this is July 25th, but if you go to the additional sample data, you have a June 4th and June 23rd. So I want you to download just ortho only, multispectral, so that we can do the multi-temporal kind of comparison. So coming back to this project, now we are going to create a new flight. Now I'm going to say flight 2. I should change the name, but this June 4th was the June 4th, 2022. Same set of 40 meter, 85% overlap. This is just for information, so it doesn't have to be exactly the same. So I'm going to create a new flight in flight 2 over here. Click create. Now you see another flight. Let me know if I'm going too fast.
I'm still downloading.
Okay, I'm going to wait until we are done with uploading this data for now. Then
It seems to be getting stuck at 100%. It just says uploading 100%. And then
Okay.
it just kind of sits there for a while.
I hope, let me see, let me go to the check what is happening. I hope that the server is not overloaded.
I was going to say, I think it could be everyone's hitting the server.
Yeah. Or it could be in here.
Good stress test so far.
I think the server is doing fine.
Oh, sorry.
It might be just network here.
My stuff started freezing too. It might be the one
Really?
here. Yeah.
I mean, this is the server that I'm running right now. We're pretty underloaded, so.
The next one.
Mine's about half done. So.
Okay. We still have about an hour for the first part.
Not for this one. If you make a flight for the next one.
Yeah, we're cooking with gas. Alright.
Was it the ortho RGB or the multispectral?
Multispectral, because RGB is too large, so let's start with a small
So,
example.
sorry, going to create the second flight for the additional
Yeah,
sample data?
yeah.
Alright.
So let's just upload one because, it's just so that you can have a multi-temporal comparison. So for the June 4th,
Go back to workspace to create a new flight.
yeah, so go back to the workspace. At the bottom, add new flight. And give a name, date, same 40 meter, 85, 85, RGB, Phantom 4, and click create.
I'm sorry.
Yeah.
Under projects or under workspace?
On the workspace, choose the project. Inside the project, you just create a new flight.
Okay,
Then go into manage data, click upload the data product, choose ortho, and drag and drop the multispectral, because this is smaller one. Click upload file, then it should be going. I think it is Wi-Fi, because I was the only one uploading it. It just go very fast. So once click done, it will show up. So so going back to here, you should have 2 flights.
I think you're too fast.
Okay.
Additional. Okay, yes.
And so I'm sorry, we're doing point clouds for this?
No, just multispectral only. Multispectral
But the
ortho.
ortho,
Yeah.
yeah.
But you can upload everything later, so they can do the comparison. But yeah,
I meant for the purposes of this.
I have so much things I want to cover, so I kind of in a hurry. I want to.
So, yeah.
And later I'm going to show you the pre-prepared project, so that the second part of the presentation you're going to work with a much larger data set actually. So
It's just the 2 orthos, right?
just upload the multispectral ortho for the June 4th. So what you can do is that in this data product page, you have a card on the left, so you can go other flight. You just go back and forth. So each of these data product, there is a multiple button. You see the view button here. So let's say I want to see this also for July 25th. If you click that, now you're going to go into this area, then they're going to show you this in actual orthomosaic images that you uploaded. So what is happening behind is that, like I mentioned earlier, we uploaded everything as a cloud optimized. And we just have a dynamic tiler running on this server. This dynamic tiler is consuming this also and showing into the time map. And the good thing about here is that we are doing dynamic tiling, so we can do the styling on the fly as well. So this is a multispectral imagery. So you can just do different min max value. Right now this is set to min max.
I'm sorry, how did you get to this page?
So going from the workspace, I'm going to go to the FOSS4G example. Or somebody might have add me as that viewer. So I'm kind of FOSS4G over here. This is mine, I guess. Yeah. So going into manage data, this in an ortho card. You see this in a view button.
Yeah. I'm sorry, which?
View.
That one.
Orth. Yeah.
Okay.
Click
Okay.
view. Then you're going to go to the page where we can actually see it. Now you can zoom in and out. As you zoom in, higher resolution image will be landed on the fly. And also you can do different color combination as well. So this is a multispectral. It has 7 bands. So first 3 band is an RGB, 4th band is green, 5th band is red, 6th band is reddish, 7th band is near infrared. So if you do the 4th color composite, this might be different sensor, but let's do different color combination. So 6, 4, 5. And click apply changes. Then now you're going to see these images with a different color. So we have a more than 3 band. You can choose whatever 3 band combination that you want to do. Then we can just do this in the rendering on the fly as well.
Nice. So,
Okay.
looking at this, I only have 4. Oh, I'm sorry.
So I'm just clicking this button to choose the 6, 4, 5 combination.
Yeah, I only have 4 bands for the red.
Oh, probably you uploaded the RGB then. So if you go to the 1, 2, 3, this is a natural color combination. So coming back here. So this is what we see in the field. And you can just do whatever band combination that you want to do. They will just give you a different color every time you just do this. Yeah. Okay. So if you like this in a view, what you can do is click Save Changes. Then next time you just open this up, it will show up as what you saved last time. Good. And yeah, I'm gonna give. And on this view on the left, so you have an orthomosaic for that flight. We have a DSM and point cloud as well. If I click DSM is a single band, not a multi-band. So once you do this, now it will show you actual digital elevation model with a color range on the left. But you can also change the color lamp to something else. So I can choose jet, then they're gonna just change the color. You can just do min max value. So let's say it is ranging from 187 to 188, pretty small range, but let's say I want to only show up to 188.1. Click apply changes, then you're going to see this range is going to be landed on the fly as well. So you can just do pretty much anything that you can do in QGIS here on the fly as well. But I'm going to go back to the min max and click apply changes. This is how it's going to look like. So this is the visualizing multi-band and single band. If you just click this in a point cloud, there's going to be new window will show up, and it actually lets you see this in a 3D point cloud. So you can just zoom in and out and turn it around. And like I said earlier, this is a soybean, and this is another LiDAR. This is an RGB 3D reconstructed in a point cloud, so their detail is not as sharp as in a LiDAR point cloud, but at least you got an idea.
Is that because it's a cloud optimized?
So we do cloud optimized the point cloud data format conversion in the cockpit. Then we are streaming this in a cockpit to this part 3 viewer.
Is it because of the conversion though that it loses some of that accuracy?
No. So,
okay.
But the original point cloud itself is reconstructed from RGB imagery.
Okay.
So their detail is not as sharp.
I see.
Yeah. There are other very detailed 3D point cloud model. For example, if I just go here, let me just give you an example. You guys don't have an access to this one, but for example, RGB. This is another data set that we process with a lot higher quality in an RGB camera. So if you just increase the budget all the way, and let me just show you. So this is in one of the Purdue building here. You're gonna start to see all those details from here.
LiDAR is magic.
Yeah. But anyway, going back. And another way of defining your projects, and now if you go to homepage, you're gonna see probably only one project, so you're gonna have only one marker show up. So probably if I go back here and going to the Purdue campus, this is in a Purdue farm here, and let me just scroll down. FOSS4G. Let me just zoom out a little bit. Where is that? Yeah. So you just choose this one. I mean, from the map, just choose click the marker. You will come to this page directly. So now you have flight 1, expand this data product. You see this in orthomosaic DSM and point cloud. You have another flight created with the orthomosaic over here, right? So what you can do is that at the top, this is in a single layer view. You can do side-by-side comparison. So if you choose this button, now it shows up. Now I can choose different flight. I'm going to choose earlier flight on the left and next flight on the right. So also over here, now you start zoom in. You can just scroll left to the left and right. I changed this. Let me go back fix this.
I see.
Let me just, so that we can just do one by one. I'm sorry I'm going too fast, but let me fix something really quick so that you can just see a lot better. Let me see, apply changes, save changes. What I'm doing is I click this, the icon with kind of, what is that, scale. Choose this one. On the left, I'm choosing an earlier flight and a later flight. Okay. Now you can just turn this side by side. So this was right after planting. On the right is about a month or two later. So you can compare how much this crop has grown over time. So you can just do this in a visual comparison over here. Okay. Another thing that you can do here is now, let's say you uploaded this in orthomosaic images. I want to share this with others. There is a button at the bottom left called Share. If you click that button, now you're going to see it is restricted. meaning that only you and whomever you added as a member of this project can actually see this data set. So no one else can see it. Even though they have a URL, they cannot see. We just do it in a backend filtering. But if you just copy this in anyone, now there's two buttons here, copy file URL. If you send this link, that person can actually download to their machine. Or if you just copy share URL, I'm going to open up this the private window where I'm going to paste that link. Now I'm not signed in here, but that person can actually see this data set through the link. You can just zoom in. Then they're going to show whatever the view that you saved, they're going to be able to see this data set as well. So like I mentioned earlier, YouTube analogy, you just create a video content, upload to YouTube, send the link. You create the geospatial data content, upload it here, do whatever manipulation you do. If you want to share with others, just open it up, send this link to via email. The other person will have a way to actually visualize it like you do. So let me play some the things. Okay. Some the extreme example that I can demonstrate. I know you don't have an access to this one, but I was in Ecuador about a couple of months ago. We collected this data set. This is about 2,000 acres. This is in a huge area. Once I zoom in, let's say this is about highest resolution that you can get from aerial imagery. But we also flew this area with the UAVs. So let me just open this up. Now we start to see the details. Wow. And this is about 170 gigabyte orthomosaic file. What I can do here is, I wish, I click share button, I already make it available. Copy this URL. You know what? I can just go back here. I think I should be able to paste it here.
What were you studying, or what was the use case?
So we participated in a competition called the X Prize Rainforest. So we are one of the finalist team. So task is given 100 hectare, about 250 acre area. We are given 24 hours to collect the data, 48 hours to analyze it, so that whoever generates the most insight about this biodiversity in that area wins the competition. So this Ecuador was the location that we visited for practice before the final. So I copied it. I wish I can.
Cannot. Yeah, because I already edited the form.
So Qiusheng, let me send you the email.
Okay.
If you can just paste the link.
Okay.
Yeah. So that TBS. So coming back, let me just. So he's going to be able to paste that link over here. But to give you an idea, if I just open up new window, let me see. Going back. Copy and paste the link. Now you see we have 170 gigabyte the imagery over just single URL. Now I can just
paste the link in the Google Docs so
Yeah.
you can access now.
So now you should be able to see zoom in. Of course, I think Wi-Fi is kind of slow here.
It's very pretty.
Yeah.
So you identified species and then just did
Yeah, so we do,
biodiversity?
we do, species identification. We have a LiDAR data over this area as well, so we just quantify the structural complexity and all those kind of stuff.
How many species did you identify?
I mean, we can say that there are different species, but there's nobody who knows all the species out there. This is in such a remote location. It took us for 3 days to get in, 4 days to get out. And that there is nobody around this place, within 9 hours, so. But you just, got a link. You can just zoom in. You can see all those, details.
Did
You wanna
anything go wrong out there? Did drones break down?
We're lucky that we didn't crash at all. But you see the power of this platform now. You can upload this data. You can access it, You can share this with others, very easily. The even beauty is that now all of this data set that we created, now you can stream into other, the platform as well. So what I want to do is, I know we are getting close to the time, so I'm going to add you to a couple of projects. So let me just go here, Purdue campus. So this is aerial imagery over Purdue campus. Purdue has, Indiana has a statewide ortho imagery program. So they are acquiring statewide ortho every 4 or 5 years. So you see that 2013, 2018, 2023. We also have statewide LiDAR as well, airborne LiDAR. So we have 3D point cloud and DSM, the canopy normalized height model, and etc. So I'm going to add you to this in the project so that you can see it. So give me your name so you can study Qiusheng. So I'm going to add you to that. Next,
Colin, C-O-L-N.
let me just add you. Then
Rebecca, R-E-B-E-C-C-A. That's me.
Rebecca. Then
Steve, S-T-E-V.
okay.
Damian, D-A-M-I.
Then
T-Y-L-E-R.
okay, Tyler. You're
Ronan, R-O-N-A-N.
R-O-N.
N-A-N.
Okay.
John, J-O-N.
Jonathan. J-O-N.
Yep.
Which one? Last one. Then
Rob,
which one?
Dennett, last one.
Okay. So now if you go back, click home page, now you should have one more marker available. So the one that we are going to see is in a Purdue campus. This is the one that you're going to see if you click the 2013 orthomosaics. And it's kind of slow. Oops. Something is going on.
Okay.
We're having some problem with the T-Tyler. T-Tyler is sometimes using up a lot of resources. Wow.
Is it using it right now?
Yeah.
No, it's only when you use Python, right? Right now it's not
No,
using.
actually, all this rendering is using T-Tyler in the backend.
Oh, okay.
So it is overloaded right now. Probably we may have to restart the T-Tyler. Minyoung, can you go talk to Ben and see if we can restart the T-Tyler? Yeah.
I will check.
Yeah, thank you. Yeah. We're trying to find the best setting for T-Tyler option. We also, this is in a one node where we have everything. We're trying to, to balance the load a little bit. So we already installed the T-Tyler on another, node, but they're trying to figure out how to kind of balance them. So
T-Tower?
T-Tyler is another open source project where we can do the dynamic tiling services.
So basically you have the GeoTIFF hosted on the server, and in order to render it to the web browser, you need some kind of middleman. So the T-Tyler is kind of the middleman. So basically you have a movie you want to share with your friend, but you cannot your friend cannot go directly to your movie. So I need to basically have the server to basically render the tile. So basically when you zoom in and zoom out, it's getting the tile dynamically. Otherwise, for the GeoTIFF, it can be 100 gigabyte. You cannot just render it 100 gigabyte all at once. So when you zoom into the area, it's going to basically, it's the pyramid, the level. So based on zoom level, based on your area, it's going to grab the thumbnail. The idea is the same as you looking at Google Earth. The imagery is like huge, like tons of terabyte.
Yeah.
So it's zooming, you have a small area, you have high resolution, it's getting just the thumbnail of that. So it's basically getting all the tiles. So you're subdividing your image into smaller tiles, and there are multiple zoom level. So it's based on the zoom level and calculation, get the tiles. So basically, T-Tile is the middleman to do all those pre-processing.
we are doing dynamic tiling. Google Earth Engine is static tiling. They already pre-render images, save with the PNGs, and you just stream those PNGs. That one, it doesn't take that much of a load, but we can do different color combination, different color map, all those kind of stuff. That's the reason why. Yeah.
Yeah, it's dynamic,
Yeah.
so you can change the camera.
Yeah.
Yeah.
So it's stored as a vector or stored as a raster?
Raster.
Raster.
So the raster tile.
Two tiler, yeah. We're also working on the importing this vector and the service and the vector tile as well. So that's going to be a coming feature.
Keep it as a vector and then render and
Yes.
cache the
Essentially,
raster.
vector tile. So we just don't stream all the data depending on the zoom level. You only stream small set of information so that you can see this in a vector at the resolution that you're looking at. There are the vector tile format.
Got a little bit of data.
Yeah, you have a little bit of data. It's not loading to me, so probably we'll have to restart it. But you got an idea. You now have an access to all this. What I'm going to do is that I'm going to switch to QGIS and show you how you can access this data set. This QGIS should work because QGIS is going to do the rendering. You don't need to do the rendering part. So let's go to the QGIS over here. And go to plugin, manage and install plugin over there, and search for D2S. If you see this in a D2S, there should be a D2S browser available. Okay, click install plugin. And I already have it, so I'm not going to install.
The powers that be are going to let me do that.
We're recording this. We're going to make this in a recorded version available so that you can always catch up later. Okay. So once you do this,
Restart.
okay, restart it. So maybe it's just a matter of me doing it. Yeah, auto load is. I'm not going to do it. I'm going to go back to the QGIS. So coming back here, go to plugin. There is a D2S browser. Browse D2S data. You can do it this way. So open this up. Now this is developed as open source. So let's say you have your own instance up and running based on this one. You can type in whatever the URL of your instance is. In this case, the one that we are working on is ps2.d2s.org. Okay. Give you a name and password. I need to make sure I'm edit this video because I'm exposing my password right now. Come back here. But whatever password that you got, right?
Okay.
Am I going too fast?
Oh, I got a warning of please request an API key.
Oh yeah, that's the part. So the other thing that you need to do is that we need to do the authentication. This in a web, we are using JW token, but this in a browser doesn't have such a thing. So you need to go to profile. There is in a revoke. I already have my API key. I also need to blow this out. I'm going to edit this part, but you need to request an API key over there. Okay, so you need to click that button, then you're going to see it. For some reason, your API key is kind of compromised. Revoke it, just create it again. Then you're going to have a new API key generated automatically. So in order for this D2S browser to work, you need to have this API key created. Everybody good?
As good as I can be.
So once you have that one, type in this in a PS2, your email, your password, click login. And what's going to happen is that now you are logging into your all the project that you got. In my case, I have everything. You should see two, right? So let's see. I'm going to go to Purdue campus. Where is it? Purdue campus. Choose this one. Then you're going to see 3 flags shows up there. Okay. So let's say I want to add 2013. Choose also from the data product. Click add to selected map. So once you click this button, now what we are doing is that we are streaming this aerial imagery from data to science to QGIS. So let's say, remember this, I think it's about close to a gigabyte, but this is over the Wi-Fi. We have a lot of people connected to Wi-Fi. It is pretty good. So once you zoom in, you're going to see more details over here. So you see that now they're streaming this part of the region at the resolution they're looking at. You see the the progress bar at the bottom. So it will show higher resolution soon. I hope so. It's not that overloaded.
Was that D2S browser just an extension in QGIS that you installed?
So this is the plugin that we developed and published it. Yeah.
I'm sorry, what does this do, the plugin?
So let you access all the data you have on D2S inside QGIS.
Okay.
So now you see high resolution images available. Going back to this D2S browser, now you can choose different flight. Now for this one, I have a ortho, and I'm gonna have a DTM, which is a digital terrain model. You also have hill shaded images. I'm gonna add NDHM, which is a normalized digital height model. Essentially, we have a top of the surface, bottom of the surface, substrate between top from the the bottom to the bottom. We just have all the height measurement from the ground. So I'm gonna add this data product, add select to the map. Then now you'll start to see this is a hill shaded images, and this is an ortho. They are showing you one by one. So this is a 2018 ortho. This is a normalized digital height model. Once you load here, this is exactly the same as a geotip in your local machine. So if you just right click and go to symbology, I can change into pseudo color. And I know this is normal at this high model, so it should be height above ground cannot be negative. So there might be a couple of pixels that's kind of outliers. I'm going to set this to be this one. I'm going to set to 200 so that I can have a little bit better contrast. So you just change this value, then you can just show in. You can do whatever rendering that you want to do, but the only difference is that your data is coming from D2S in a stream.
Coming from what?
D2S. So you don't have your data set here on local machine, but you're streaming this data set from the cloud to your QGIS. Now, if you want to do some analysis, you can run this analysis over here, but the thing is that if you have 100 gigabyte of file to the analysis, when you ended up streaming all 100 gigabyte to a local machine, so probably you don't want to do this. And what you can do is that if you have a large file, there are small subset area that you're interested in, then you can clip that images, save it to a local machine. From there, you can do the analysis if you want. Okay. We can also look at these hill shaded images. Let me just do this DTM. Let's do the same thing as an earlier. Let me just do pseudo color. I'm gonna just apply. And one of the neat trick that I like from this QGIS here is that you can do the layer blending. So I can just multiply here. Now you can have blending this in a hill shaded images in a column map here, so that it, this digital terrain model looks a lot more kind of realistic as well. Okay, I think this is pretty much everything that I want to cover from my part. I think I finished a little bit earlier.
No, it's only 1 hour.
I know, but this is, any question? I mean, the second part is going to be a lot more interesting. And now you can do coding with this in a data center D2S as well, in combination with the orders in the Google Earth Engine catalog.
That's cool.
Yeah.
And keep in mind, this is an open to public. I get a lot of questions, how much data I can upload. You can upload as much as you want at this moment. Because we have about 200 terabytes of storage. We're only using about 7 terabytes as of now. So I'm trying to grow this community so that the people know about it, start using it, and start to share with others.
It's really well designed. I like it. Yeah, I like the approach you guys took.
Mm-hmm.
If it takes off, how are you gonna scale? Like you said, right now you can upload as much as you want. At some point, if this takes off.
So I'm at academia, so I go to federal. No, what I'm saying is we can go to federal agencies, USDA, NSF. So give us some money. So I'm trying to build this in a community, show them, hey, this is cool. There's a lot of people using it, love it, and I can convince those federal agencies saying that, hey, we have this great community built. I want to sustain this community to be growing, and asking them give us some money so that we can keep developing this to much larger scale. So that's my plan. So now.
You can also deploy your own instance.
Yeah.
You can host yourself.
Yeah.
Then you don't have to do like through this.
Yeah.
Does it still involve the cloud if you're self-hosted?
So if you have your own server, you can deploy. Everything is Docker, so you can deploy in AWS, Google Cloud, Microsoft Azure. It really doesn't matter. But the thing is that, this cloud is cheap to get started, but as your storage grows, your bill can go pretty high. So if you have a small group, you have a small, very certain, storage requirement, you can get started with, the AWS. It only takes, let's say that I want to start a new instance, it'll take, less than 5 minutes to create something on a new instance. We can get going. Now you have a full control. You are the, admin of these instances. You can just do whatever you want.
I'm sorry, you're talking about like a D2S clone self-hosted?
Yeah.
Okay.
Yeah. So, the basic idea is going back to this document here. Where is it? So this document here, deployment is Docker 101, building Docker images from the source. So we have a GitHub repository where we hold the source code available. So if you want to build your own Docker images, you can do that. And you can just run Docker containers using local or remote images. So we have a Docker hub repository also available. So you don't need to do a build. You can pull from this Docker hub directly to create a new instance as well. But of course, you need to have resources to do so. You need to know how to deploy, how to manage servers, and all those kind of stuff. But one I want to say is that you have a free version that is available to you. Please spread the word. Let's others to use it. I want to grow this community.
Powering down? Is it out of battery?
Maybe. Yeah, I think good timing. Right? Plus, it's time to break. Take a break. So, any other questions?
Not a comment.
Okay. You have my contact. The way you can find me is if you go to Google, my name in Purdue, and this first will come up at the Google. So this is me. So. You can send me an email if you have any question about the part that I did. I know that there's going to be another exciting part for the second half. So if you don't have any question, we can take a 10-minute break. So it's 10:10. So let's start second half at 10:20.
Thank you.
Okay. Yep.
Thank you very much.
Mm-hmm.
Yeah.
All right, let's get started. So the first hour we have gone through the D2S platform and accessing using the platform and also QGIS. So in the second part, we're going to actually use Python to do some coding. So before we get started, I want to know how many of you have used Python? All of you? Perfect. So I don't need to cover the basics. And so we're going to use Jupyter Notebook on Google Colab, but you are welcome to install the software packages on your local computer if you want to. And just to make things easier, so I'm just going to use Google Colab. And so on this Google Docs in here, so click this link, geemap workshop. So if you click the link, it should take you to this notebook. I also sent the link, I think yesterday, so you should have access to this one. So do you all have a Google Essentials account? Sign up? If not, you can do it right now, just a Gmail account, and then you can have access. But you might need to enter your credit card because it needs, it gets changed to, right now it requires so-called Google Cloud Project to do authentication, but it's free, so you don't need to pay anything for research or educational purposes. But you do need that Google Cloud project. But Google Sensing itself is free for research, education, and non-profit. You're welcome to play with it, but later if your company or your government or agency want to use it for commercial purposes, then you do need a commercial license. But for this training, we're going to just assume there's going to be education and training. So for here, you are welcome to, you have seen here on the left side, there are a lot of workshops that I have taught in the past. I talk like a couple times every year. So GMAP is a project that I started about 4 years ago during the pandemic. So at the time, I think in 2010-20, so Google Sensing mostly JavaScript. They have the Python API, but the visualization part is very challenging. So I created a package to make it easier for people to use Google Sensing. And so last year, it has been officially adopted by Google Sensing. So now if you want to learn Google Sensing, you want to use Python, most likely you're going to use GMAP. So you can click here, take you to the Google Sensing website. And under the platform here, this one, co-editor is the one where you actually do coding using JavaScript. So if you click the co-editor, you're going to ask you to log into your account. So this is where you actually do all the coding, and this is for JavaScript. But for today, we're just going to use Python. So you can do pretty much everything very much similar to the JavaScript. But this is just that you know that if you want to learn the JavaScript, you can do it here. And the other thing I want to cover here is this documentation. So this is where all the tutorial examples of how to use Google Sensing. So for those of you who are not familiar with Google, how many of you actually use Google Sensing before? Okay, half? Yeah. So Google Sensing, for those of you who have not used it, Google Sensing is different from Google Earth, okay? So Google Earth is like for visualization, that's it. There's no really analytical functionalities. Google Sensing, on the other hand, is like you can visualize, you can have access to the data, you can also do analytics. And some of the imagery might be common, but the commercial high-resolution imagery on Google Earth would not be available on Google Sensing. So those are like commercial purposes. So the analogy would be like kind of Adobe Photoshop compared to the Windows image viewer. You can view images, but you cannot really do a lot of analytical stuff. So this is very powerful, and everything is streaming on the fly. And Google Sensing, I want you to, the take-home message is that why it's so powerful is doing computation on the fly. So imagine you have an image that's 10 gigabytes covering the entire globe. When it's running the computation, it actually depends on zoom level, depends on the area, is subdivide the area into smaller pieces. And each one is sent to like one of the servers. So they have tens of thousands of servers on the Google Sensing. So it's running the computation, return the result, and then you put it all together. And it looks like it's like one seamless imagery, but it's under the hood is like there are thousands of computers to do the same thing and then return the result. Very much similar if you see the imagery on Google Earth. When you zoom in, it's very fast, you see the high resolution. But under the hood is like one PNG, basically a thumbnail from a lot of computers. So this is why it's so fast, and it's very powerful. So we're going to see how you can create, for example, global mosaic in seconds. Like rather than have to download the data, gigabyte, takes you a long time. But this is something that going to change your workflow. And so again, you're welcome to try it out. And so here I'm going to quickly show you, for example, if you click the guide on the left side here, there are a lot of examples here you can try out. So if you click any of those imagery, and then on the right, you're going to show you, for example, JavaScript and also Python. So you can either use JavaScript or you can use Python. So for the Python, if you can click here, it's going to show you use GMap. So GMap has been officially now adopted by Google Sensing that you can, it's very much similar to the JavaScript. So you can access whatever using whatever language that you are comfortable with. And we don't have time to cover all this. So I've taught workshops ranging from 1 hour to a whole week, 24 hours, like every day 6 hours. Like basically you can, GMap itself, I can talk like the whole week. So today we're just going to give you some essential functionality, but you can learn it by yourself. And a lot of workshops here, and also on the left side, there are notebooks. So I've developed over 150 notebooks. And so every notebook introduces a couple new features of the package, and there are tons of more. So also I published a book on the left side here. You click the books, it will take you to the Google Sensing book. So this is the one that I wrote introducing GMap is open access, so you can take a look at the content, all the notebooks. So what we're going to cover today, probably cover maybe 10-15% of what the book is about. But you're welcome to study by yourself after this. And you can open the notebook, for example, on Google Colab and log into your account, then you'll be able to run data analysis at scale. So Google Engine is really powerful for doing raster data analysis, and you can do things really at scale at the entire globe. But in terms of vector data processing, it's not that super efficient. You can still do something, but for vector data processing, they have the BigQuery, and also I think the Wearbots also has Apache Sedona. They can do a lot of large data processing for vector data. But we're going to get into that very, very quickly. So again, I'm going to go back to the notebook example that we're going to use here. So if you go to this one, you can just right click here, open in Google Colab. Then it should take you to Google Colab. So from here, you can just use this one to follow the notebook. So on the left side here, upper left corner, there's a table of contents. So this is a pretty long document. It's just a Jupyter notebook. So you're welcome to use this one to navigate through, because later on you might encounter some errors. You might need to restart the kernel, rerun it. Then you use this one. And so the first step you need to do is to install all the packages. So the first code block here, you can press Ctrl/, or you just manually remove the hashtag at the beginning, and then just click run. Of course, you need to log into your account first. Then just click run, and then run anyway. So this one, we're going to install all the packages, pretty much GMap, LeafMap, and also D2S. So those are the 3 packages that we need. And LeafMap is another package that I created. It kind of is a spin-off from GMap. So GMap is designed for Google Engine, but LeafMap is more generic that you can use on any cloud computing platform. So LeafMap have been used by, for example, Microsoft, NASA, and a lot of other open source projects. So if you want to learn more, you can also go to leafmap.org. You should be able to find the website for LeafMap. So it's very similar. So the idea is the LeafMap built on top of a lot of mapping libraries. So you can use, for example, IPyLeaflet, Folium, DeckGL, CableGL. It's basically very similar API. So the consistent API to create a map. So basically you don't need to learn all the libraries. Kind of like if your goal is to watch a movie, you don't really care is it YouTube or Netflix or Amazon Prime. All you need is just similar interface, and then you can start streaming the data. So LeafMap basically should help you do that. And if you want to see everything is open source, you can go to the GitHub repository here. And I also created many other projects. So if you go to Open Geospatial Solutions, so these are all the open source packages that I created and maintained. So you're welcome to help. And so GMap is probably the most popular one, and then also LeafMap. And the other one popular is Segment Geospatial, doing segmentation. Today we don't have time to get into that, but if you want to learn more, you can check out the repository. So after you finish the installation, then you can just clear the output, so it's not taking too much space here. All right, and also provide instruction here if you want to install that locally.
So you see the D2 file, this is a D2S hyperparameter. That D2 file is the hyperparameter, which is the data set.
And yes, so this is the instruction. If you're familiar with Conda, then you can install it locally. Then all you need just import the libraries. So we're going to use EE, basically it's the Earth Engine Python API. GMap is the package to help you visualize the data from Google Engine, and LeafMap is have a function that you can get the tile from D2S. So basically, I'm going to stream the data. So D2S, the data is from in the cloud, but keep in mind the D2S data is not on the Google Engine data catalog, so it's not optimized. But we can pull all the data together on the same map, so we can have access to basically multi-source of data. So LeafMap can help you visualize data locally, data from Google Engine, and data from other cloud providers. As long as cloud optimized GeoTIFF, you can stream the data very easily. Okay, and the next step is to initialize Google Engine. So what I would recommend here is to, if you first let you log into your Google Engine account, and then click the code editor. Upper right corner here, click. So if you don't have access to website, again, you can click this one here, Google Engine. Log into your account.
So upper right corner here, what we need is your cloud project ID. So do you see this one somewhere here? If you create a new account, you should have this one somewhere. Like, so for me, it's EE-book. But whatever project ID that you have, you can also click the project ID here, and then just copy this one. Okay, EE, for me it's EE-book, but you might be something else. Can you get this one? And then once you have that, come back to Google Colab. On the left side here, the second last one, there's a key. So basically, Google is saying now require project ID so that it can check the usage. But again, this is itself is free, and so Google just make sure that you don't abuse their services because it's free. So you need this one to connect to your cloud project. So on the left side here, what you can do is add a new secret. And so the reason we want to do this because if you have this is basically the environment variable. So if you can detect, you don't need to authenticate every time. So it's better to just add this one. So add new secrets. And then from here, the first one is the key. So you just type EE_project_ID. Okay, so EE_project_ID.
Sorry, did you show me when
The find ID is go to your Google Sensor account, and then the platform, and then co-editor, then upper right corner here, whatever you have under here, you should have this one, or you can click the project information, and then from here just copy this one. If you have created an account long time ago, many years ago, you might not have this one, then you need to register a cloud project. So once you have that, and then EE_project_ID, and then just paste whatever your cloud project ID here. Make sense? And then on the left side, just turn on this one. Because I already have the same key, so it won't allow me, but turn on this one so that your notebook has access. If you already know Python, this is basically just setting an environment variable. So it's going to reading this one. So from now on, you don't need to actually, you can uncomment this one to set it, but it's better to use the environment variable, so everything else will be automatic. So after that, just click this one, initialize. So yes.
So if you are running this locally, you have to uncomment the whole.
No, you don't. If you run it locally, uncomment this one, and then you'll be changing this one to your EE project ID. So it's like EE, whatever. But if you use Mac or Linux, you can also set that one as environment variable on your computer. Windows, you need to go to your environment settings. So basically, it's an environment variable. You can choose to set it manually every time, or you can just use the environment variable. So for me, I'll just click this one, and it should pop up this one. Allow this notebook to access your Google Earth credentials, and then just click allow. Okay, and so the next is going to pop up this one. Log into your account. Just select. So you're going to access your Google Colab, and then continue, and then continue. All right. So you need to make sure you can pass this step, otherwise you won't be able to do anything. Is it done?
Yes.
Yes?
So I think the screen that we see here is different from yours.
Yeah.
Continue.
So just run this one, it's going to pop up, ask you to register. And so for those of you who already finished, just click this too. And then the next one is like grant access.
Yeah.
You probably don't see this one because I have a Google Maps API key. You might not have this one, so it's up to you. So for me, I can. It times up. If you click and then run this one, so run the next 2 code blocks. If you can see the map, you are good to go. Everything has set up successfully. If not, let me know. I can help you out because otherwise you'll be just watching. You cannot really do anything. So, how many of you can see the map?
I see a map.
The map?
I'm way behind where you are.
Okay, so
I was.
do you have an account now?
An account.
Also, upper right corner here, click this one. Okay, here. Yeah, click. Yeah, and then project info. And then copy the project ID. Yes, select this. No.
I have it already.
Oh, already. And then you can go to Google Colab. Go to the Google Colab. Not here.
To this? No.
Yes, this one.
Okay.
And then on the left side, there's a key. Second last one. Yes. And then create add a new key. EE. No, this one is EE_. uppercase, all uppercase. EE underscore project. And then underscore ID uppercase. And then paste your this one here. Control V. And then hit enter. And then no enter, but on the left side here, enable that button here. And then from here, have you installed the packages? This one here. And then click, scroll down, and then execute this block.
This one?
Execute it. And then scroll down to the next one. Yeah. Initialize. No, next one. Yeah, run this one. And allow access. And then allow. Okay, log into account and then click your account. Allow, continue. Continue.
I gotta do all this when we're done.
And then just select all. Yeah, select all. Yeah, if you pull up the dialog, if it's different, make sure you check the boxes. I forgot, like, if it doesn't, you can restart the kernel, you can run it again. Continue. And yeah, if it's successful, then run the next code block, map equal to geemap.map. Okay, and then display the map, next one. Okay, you're good to go.
I'm not in.
Anyone else having issues?
Yeah.
Still working on it.
Still, let me see.
You have to restart it. It says geemap's not defined. So.
Oh, Gmap is not defined, then you need to, have you installed it?
Yeah, I keep getting the list of green check boxes. Everything looks good. That says you're not good. So it'll run this.
Yeah, import. Run this one. And then, whoops.
Wait, because that's still running.
Yeah. Okay.
Yeah, wait for, is it finished? Let me see here. Yeah, it's already finished. And then run again. More has restart the kernel. Maybe here, runtime. Restart section.
I see.
And then yes. And then click this one again. Okay, and then scroll down. Initialize again. You don't need this one. This one. And if you pop up here, allow.
Okay.
And then select your account. Continue. Check the two boxes. Select all. And then continue. Then you should be good to go.
Okay.
Are you having the same error?
I have a different name. I'm on this one.
Yeah, so here you need to set it's EE project ID, not your project ID. EE uppercase. Or you might need to delete it. It doesn't allow you to change. So delete it. Add a new secret. EE underscore, no hyphen, underscore project.
You need to log into
underscore ID, and then the value, paste whatever you get from your account, project info. Oh yeah, that's fine as well. Okay.
Too many
And then paste, and then enable the button on the left side. Yes, click on that. Oops. Okay, and then click that one again. Hopefully it works. Okay, and then scroll down to see the execute this one. You restart the kernel. Probably you need to maybe runtime. Restart section. Down. Yes, and then yes, and then go back to import E and Gmap again. Go up. And then go down. Initialize. Run. Next. Yeah, run this one again. See if it works. And then this one. If it doesn't, you might need to reinstall it. Okay, and then map, display the map.
This one?
Yeah. No, the one above. Oh, it's okay. Oh, okay, you're good.
I'm good?
Yeah. If you can see the map, you're good.
Okay.
It's okay.
So you.
He has multiple accounts.
Multiple account.
So he was in the mix now.
Yeah, use whatever account that you already confirm. Yeah, you just need a cloud project. Okay. What else?
I go through, I've already done this.
Allow.
I choose the account that I have registered with.
Next.
Next. Continue.
Continue.
It's already
Continue.
authorized.
And one. It's still error?
Still error.
Credential propagation was not successful. So how about this restart rolling time and restart section? And then go up, import the geemap, this one here again. And then click this one, allow.
I need to.
Is it a new account or? Okay, this one, okay. And then get the continue.
Here.
It's still error?
Still errors. Maybe, is this wrong? No. That's what that is.
EE project. Yeah, it looks fine. So how about this? You copy the. Is it logging to your same account? Is this one? Okay, yeah. So if you in Google Colab, if you log into a different account, then you need to make sure you switch. Otherwise, so your account and also your EE project ID is tied to your account. So if you log into a different account, your project that doesn't exist in your account, you will get into errors. Okay, so all of you can see the map now. Okay. So I wait for you, and then we can continue. And if you see the map, the default one will be OpenStreetMap. So for me, I see the Google Map because I have the Google Maps API key, and I'm not going to cover this one because you need to get the Google API key to be able to use the Google Maps services. But it doesn't really affect anything for this workshop, so don't worry about that. And so this is basically what geemap is about. Is that you can see the interface. On the left side here, you can click the button. You'll be able to basically search the data. So we cover that later. On the right here, basically just you can turn the layer on and off. You can switch, turn the opacity. And you will see here it's not, on Google Colab, there's a kind of a lag. It's not super responsive, but it works very smoothly on my local computer. Google Colab, because it had some security issues, so they check things. So for this workshop, you can just use Google Colab. So from now on, I'm going to switch to my local computer using Jupyter Lab, but the interface should pretty much very much similar. So and like I said, if you want to set it up on your local computer, then you can follow instruction. So the nice thing about on local computer, you don't need to click the authentication and then log in Colab every time, like click those buttons, like save on 8 times. Local computer is just you can use it right away. So for me, for example, you don't need to follow me, so I'll just click the upper right corner here, click this one, and then you can download this notebook to your computer. And after that, I'm just going to open on my local computer here, and I can open just my terminal, contact activate, and then GEE. So I already created one, and then just type Jupyter Lab. Then I should be able to open this one on my local computer. So here, you will see I don't need to authenticate every time, so I'm just going to run this one. Oops. Is it my computer or is it? And so here I'm going to initialize. You see, I don't need to click those buttons, so it just walks out of the box. See, and it's pretty quick. Upper right corner here. So now if I switch this one, you see, it should be a lot more responsive than you're using on Google Colab. So Google Colab is a little bit laggy. It doesn't really show you right away. But anyway, if you're interested in setting up a local computer, follow the instructions. But I'm going to use this one from now on. So let me switch. So are you able to see the map now?
No.
Let me see.
Okay. It's saying there's no project.
There's
none.
Yeah, so what you can do, maybe just double quote and then just paste your project ID in here. Okay, and then click the map, and then display the map. Oops, interesting. Google saying had not been disabled, so you need to enable it. Click this, go to the link. You need to enable the services. So you need
Oh, are you logged into it?
Yeah, you log into the same account, so.
So this one is logged into.
I think you need to go to your Google account.
Yeah, by default, if it is under your account, it should be enabled automatically. So it's probably just a different account.
So which one you find?
That's using that one. And so,
No, but it might be. Do you have a multiple Google?
no, it's just the one.
Just one. Can you click that part just to make sure? So this is your.
Yeah, this is the most tricky part for beginners. Some people are very frustrated setting this up, but once it's set up, it's just one time only, so you don't need to do that every time. So I do recommend that you install the packages on a local computer, and then you just open Jupyter Lab, then just run through the code. So everything that we're going to present in here should be reproducible. And so I'm going to go to the next section here, and so we can start going through the source code. Let me maybe increase a little bit. Is it better? Yeah. And so let's wait for a couple, 2 more minutes.
Then, yeah, back to none. Yeah, right. Yep. He didn't set this one.
Oh, okay.
Yeah.
Yeah, if you didn't set it, okay, run, see the map, click the map.
Yeah, quick.
Okay, great. So now we're all on the same page. So let's continue. And so let's scroll down to the next section here. So for geemap, it's pretty simple to use. So basically just dot map and then just create interactive map. So this is the default one, but you can customize it. So in this inside here, you can set a center, a zoom level, and also the map height. So basically this is the latitude and then the longitude. And so we use the latitude, longitude, but Google Sensing actually use longitude and latitude. So sometimes you get confused, but if you run this one, you should see a map right now, for example, center around the US. You can also hide some of the controls. So by default, it's going to show all these buttons here. So upper left corner, this is where you can source location, source Google Sensing data. Upper right here is where you can turn the layer on and off. And then, so there's a button in here. You can also click this one, you can show more buttons. So this is all geemap is about. You have loads of widgets that allow you to interact with the data very easily. And so if you want to hide some of the controls, you see right now we are turning off the data control. So the data control is this one, upper left corner, and also the toolbar control is the one on the right here, and also the draw control. So we can actually turn things on and off. So think about the map, everything just like a Lego. Everything on the map can be removed, or you can add new widgets into that. And so this is just a simple base map. Right now, there's no Google Sensing yet. It's just a simple web map using IPyLeaflet. So IPyLeaflet built on top of JavaScript library called Leaflet. If you have ever used web mapping, probably you might have familiar with this one. And so next, let's add some maps. You can add base map. So geemap.map. So there's a base map parameter. And I can add, for example, the Esri wall imagery. If you click that, so now you see I have the imagery, the base map. So everything here, you can click the button to turn layer on and off.
Sorry, where are we at?
Scroll down.
To adding base maps?
Adding base maps, yeah. First one, you run it, you'll be able to see the map right in here.
Okay.
By the way, so on Google Colab, this full screen button doesn't work, so you cannot actually click that. But on my local computer, I can full screen. If you really want to, I think you can, on Google Colab, you can right click on this code block here, the map, right click, and then there's a view output full screen. And this is where you can see them like in the full screen, but you see the height is a little bit smaller. Grab escape, and then you can go back to this one. So this is just adding just one simple base map, but you can add as many base map as you want. So for example, I can add another open topo map. You see it add right away. So this is called, it's built on top of IPy widget. So you can actually display the map first, then you can add things. So you're going to reflect on the, whatever way you display the map. You can also create multiple instances. So for example, here I can add a new code block. I can press type M, and you see here, these are all synchronized together. So if I zoom in to one map, it's zooming to another one. So it's basically the same map object, and it's linked all linked together. So if you zoom in, you move around, you see it's going to be synchronized to this one. So you can, if you want to multiple maps. So also you can add, for example, the Google satellite-based map. So this is the URL, and there's a function called add tile layer. Again, if you run it, it's add a Google-based map. So this one, right now we are using basically the Thai URL here, but this is just for testing purposes. You're not supposed to use this one for commercial applications. You do have to have the API key, but just for demonstration, you can, because this URL is public, so you can add that to the map. Well, I used to have this one built in geemap, but after it's officially adopted by Google, so there are some licensing issues, so I had to remove it. But it's your only responsibility, basically, if you want to use the Google satellite-based map. And so you might be wondering, like, how do I know which base map, like, what's the name of the base map, right? Open topo map, Azure to world imagery. So you can just come here, run this one. We can use the base map selector. So if you run this code block, add base map selector, and then upper right here, you should be able to see this one. So here you can switch to any base map that you like. So there are over 100 base map available. And so I can switch to, for example, terrain, and I can switch to CartoDB. So this is based on another package called XYZ services. So it basically accumulate all the web map services on the internet that's popular, they're free. So for example, I can switch to Azure world imagery that we added before. So if you want to basically edit programmatically, all you need is just figure out the name, whatever in here, and then you can just come here, map.add base map. Okay, call this function, and then inside here, just put whatever the name from here, and then you will add it by default. So for example, I want the, how about this one, like open, for example, open CMap or open topo map, right? So exactly like this, open topo map, right? It's add that one by default, and all the layer you can turn on and off, so it's up to you what you want to use. You can also do it this way, so just 3 lines of code, create a map, and then add a base map. Upper right corner here, you can also use the button. So earlier we used the add base map selector, but you can also click the button here, upper right, click this one, and then the second row, the first icon, you can also open this one. So you can basically do things programmatically, or you can just use the interface. So it's up to you what you want to use. And so that's about the simple examples how to create interactive map. Next, let's talk about how we can add data from D2S, right? So earlier we have covered how to use the web platform and also QGIS. Now we can actually stream the data directly from D2S to Jupyter Notebook. So run this code block, and from here, for this one, for the email here, you use change it to your email that earlier when you created, okay? So just change this one, whatever email that you use to create the account, replace this one.
Hold on, what year, the login method 1?
Yeah, login method 1, yeah.
Okay, it's just asking for password.
Yeah, don't run.
You're supposed to change.
Yeah, you can.
Okay.
You can on the left side, if you already run it, there's a stop button. You can stop it. Okay. On the left side should be allow you to stop and then change to your email. Or if you really want, you can use this demo account. So the password is from here. You can also use this okay. one. So I'm gonna copy and then come back to this notebook here. Run it. It's gonna ask you a password, and then just whatever password that you have, enter, and you should say here blah blah section. So then, can you log into any errors? Change you to your email. So this is method 1, and then so here it allows us to get the API key automatically, so that we don't have to enter the API key. So, and there's also another one. So similarly, again, change this one to your email account. Workshop, replace this one. Again, if you want, you can also use it. Just copy the password from the document, and I'm gonna run it. Again, paste it. So you can use either one, but what we want here is just to get the API key so that we can access to your project, and then we can access all the imagery. And then just run continuously. So this one says the API key is an environment variable. So that later on, we don't need to expose this API key. You'll be basically attach this API key automatically to the URL so that we can do the authentication. All good? just continue to run through that. If you run into any errors, let me know. After that, now we can use basically the D2S, right? So you can run this one. You're going to show you all the projects. So this is pretty much like what we maybe ps2. What's that? D2S.org. And you can log into account. Basically, it's all the project available. So we are right now just getting the information programmatically. So let me copy this one.
An error that workspace is not defined.
You need to. You get the same error?
You're getting error.
Uh,
So I ran this one.
so let me.
So I ran, so I logged in with this method here using the workspace.
And let's scroll down. Scroll down.
You can do the first, you have to.
Yeah. So scroll up. Scroll here. So I also run this login methods too.
Yeah. You have to run both?
Yeah, run both. Yeah, because basically all the code beneath is using the login methods too. So run this one and then change this one to your email, and then that's it. And everything else should be automatic. So basically, right now you see here, these are some of the projects available. And if you can see the project listing in here, that means you are good to go. Otherwise, you might be having some issues.
I thought it was choose one login method.
Oh yeah, use both of them, yeah. And then you can continue to run, for example, you can filter by title. So right now, for example, we're going to use the example, the Purdue campus, the last one in here. And so we're going to use this one programmatically. Just run this code block. And so this one returns a list of projects. Let me zoom in a little bit more. 150. Okay. And so this one basically is a list of project collection. And so we're just going to use the first one. So run this one again. Then run this. So we're going to show you the.
So yours might be different orders. So you filter by Purdue, I think you're going to have only one anyway.
Okay.
Yeah, if you do the filter, so you should be just the project contains Purdue, and then so we're going to get the first one from the project. So once through that, if you can see this GeoJSON, the dictionary return, then that means we're on the same page.
Okay, hold on, where are we? Project boundary.
So you have, yeah, that's one. Yeah, I mean.
Does it work?
It's going, but you're going to be faster.
So that's the. Keep going or?
Yeah, just keep going. Just run it, keep going.
Thank you.
And so this is basically getting all the flights available, right? So we basically, what we're doing here is to get access to the imagery under this Purdue campus project. That's it. So we're doing things programmatically, but on the platform, we are just clicking through, and you see here we have 3 flights, right? So if you run through the project, and at the end, you should get to this step, get the list of all flights for this project. So you should have 3, right? 2013, 2018, 2023, right? So basically, it's getting the things from here.
I'm sorry, how far down did you go?
Yeah, you can keep running step by step until you get to this one, get list of all flights for project. All right? So this basically right now we see the 3 projects, and the next step is to, for example, you can filter the data by imagery by date, right? Because right now we only have 3 flights, but you might have 10, 20. So we are continuing to filter the data by, for example, we only want to get the imagery from 2015 to 2024. So now we get down to 2 projects, 2 flights, 2018 and then 2023, right? So we are getting this one and this one. We don't use the 2013 one. And so once we have this one, the return result also is a list. Now we're getting the index 0, so we're just going to get the one from 2018. So run through that, hopefully no error, and then continue. You run it. So now we're getting the 2018, and so this one you can get the data product, right? So basically from your account to the project, and for each project you want to have different data sets. So right now we're getting all the data set under 2018. So it's basically we're getting this one. So we have 5 data products in here, right? DTA, also Mosaic, DTM, DSM, all the data sets. So it's pretty lengthy in here, but the point is that you can access all the things from D2S programmatically. And you can see the data information, you can see the file paths, and also some of the basic statistics. So this some of those are from the T-tiler. So we basically do all the statistics. And now we can filter the data, right? So we have 5 products. You can search, for example, I just want the also mosaic, right? So this will be like, okay, now I want this one. And then I'm gonna click, and then like you can see the imagery from here. I can turn the layer off, but let me come back to this one. Just run it. And so right now we are getting access to the awesome mosaics. Basically, we're getting to this imagery. And the next step is to how to visualize the imagery on Jupyter Notebook. So run this one. Hopefully it works. It might take a couple seconds. So it's going to the server to retrieve the data and then render it on the imagery on the fly. You see? Can you see this one? Yes. So right now we are getting the awesome mosaic from here, right?
Sorry. That should be zoomed in, shouldn't it?
Yeah, it's zooming automatically. So from Google Collect, it might take a couple seconds.
Okay. Doesn't look
That's
like
weird.
it's cranking here.
Does it zoom in automatically? Yeah, if it doesn't, run the code block again. So if it doesn't zoom in automatically, try to run it again. So that's kind of the thing that Google Collect is not sometimes super responsive. Yeah, run it again and then wait, don't click anything else. It should automatically zoom into a location. Yeah.
Oh, there we go.
Okay. And after a couple seconds, it's load up. All right. So here, then you can, for example, turn the layer on and off. On the right here, you can see this button. If you zoom in and zoom out, you see it's spinning. It's loading the tile on the fly, right? So zoom in, zoom out. So once it finishes loading, they get changed to this one. This layer, you can also delete the layer. Don't delete it right now, but I'm just saying you can. Okay, so see if you can see this one. If not, then we have a problem. And if you install leaf map, long time ago, you need to update leaf map. I just actually in the earlier section I fixed the bug. So if you install it long time ago, it may not work.
That's why. So I put this URL, the Google URL is unsupported. That's because.
Oh no, it's supported. It's just like use at your own responsibility. So you don't really need this one. What we want is basically I can allow you to compare the imagery, right? Yeah. So you can turn the Google Hybrid together. You can see the changes of the imagery. So you can turn this one off, turn this one on.
Which one?
The Google Hybrid.
Uh-huh.
And then this is the RGB imagery. It's from D to S. And then you can see the changes compare.
Because you haven't set the API key yet.
So basically it's
just a base map that you can compare different satellite data.
Alright.
Right.
So in other words,
Okay. Can you see the map? Yes. If you can, then we are good to go. So this is basically another way of streaming the data from D to S, right? So you can use the website, you can use QGIS, or we can use JupyterLab. So whichever way that you want. And from here, you can turn the layer on and off. There's also a Google base map in here. So if you turn this one, you can see the changes, something like this. So this is the Google hybrid base map. And so besides the satellite imagery, the Jung imagery, we can also load other data layers, right? So as I mentioned here, we have the DSM, DTM, and others. So you can actually pull all the data, whatever data you want. So the next one we're going to look at is the DSM, right? So you can filter the data using the DSM keywords. So I'm going to get this one. So similarly, you might have multiple DSM. So just getting the first one and then get the URL. Then we're going to use DivMap to automatically attach the API key because this is it's not a public file, so we need the API key to get the tile layer and then can add it to the map. So you will notice here we have this function called add cog layer. So basically, Gmap can add any cloud optimized GeoT from the internet, and whether it's a public URL or it's a authenticated URL, and then that's it. Then if you run this one, after a couple of seconds, you will see on the map here above, it should add the DSM, right? So go back. If you can see the DSM here, make sense? So now you can also turn the layer on and off, right?
I'm sorry, what is a cog layer?
Add cog layer.
No, I see that, but what is a cloud layer?
Oh, COT is Cloud Optimized GeoTIFF.
Okay.
It's called short for COT.
Yeah.
So add COT layer, and then so basically it's just you can pass in any URL and then give a name and then opacity. So by default, we're using the so-called T-tiler endpoint to render the data layer. So under the hood, it's doing something like this. So we have the imagery on the server, and right now we are using Jupyter Lab. So we're trying to render this one. So we use T-tiler as a middleman to grab the tiles, do the dynamic tiling, and then you'll be able to see this one. The nice thing about this is you can change the color, you can change the visualization, different color map. So this is called dynamic because it's not pre-render. So you can choose what color you want to use to do the rendering. So if you want to change it, for example, I can, at the end here, add code layer, I can do like color map, COLOR, MAP, name. Oh, yeah, the different one. So this one is the wrong one. So actually from here, I can, maybe we do it later. I don't want to make complicated. So run the next code block, we can add a color bar. For example, there's a function called add color bar, and just run it. Then you can go back to the map above. So you see here right now we have this color bar added. So just one line of code. So this just represent basically the range, the elevation ranges, and it's up to you. Like you can change the value to whatever value that you like. It's just an indication. So here, right, if you know your imagery, the minimum is this one, the maximum is this one. You can change it. And if you don't know like what's the value, how do you know it's this one? There's a function called geemap.cop stacks. You don't have to follow me. I'm just showing you everything. You can get the things programmatically, and then you just passing the DSM URL. You should be able to get the statistics of this imagery. So because this is the cloud optimized GeoTIFF, so you can see the minimum. DSM. Did I do something wrong? So DSM.
Oh, you didn't update the value.
Oh, didn't update the value. Okay, yeah. So it's supposed to be negative, and then yeah, I think need to change this one probably from the older version that I have. So basically, you get the statistics, and then I can change the value, for example, to -54 and then 1600. But this is just demo, so don't worry too much about that. So next, you can also get the add the vector data. So earlier we just add the cloud optimized GeoTIFF, but we can get the project boundary. So the project boundary is earlier when we get from D2S from here. So this one is just a GeoJSON dictionary, and it's a vector data. So we can just call the function called add GeoJSON, and then give a layer name. Now if you come back to here, you should have this GeoJSON. When you hover the mouse, you see that. So put to campus, right? It's basically this one. So it's just a simple polygon. And yeah, so this is how you get basically GMap. You can add any vector data, raster data, all kind of different format. So lastly, this code block is pretty long, but basically we can add all the data together on the same map, right? We have the imagery, we have the hue rate, we have the DTM, DSM. So just run this code block and let's see what happens. So basically we are getting the data product, we get the URL, and then we basically attach the API key to the URL, and then we can just use the add code layer to add the data to the map, right? So it might take a couple seconds, but hopefully it works.
Here on this, add the LiDAR data one?
Yeah, add LiDAR DM, hue rate, DTM, NDHM. So take a look. So now this is very much similar. Earlier we used QGIS, right? You can do the blending. So now you can turn the layer on and off, right? So we have the hue rate. This is just the grayscale color hue rate. And we also have the DTM. Then the DTM basically will change the opacity to 50%. So it's overlay on top of that. And then also have the CHM, so the canopy height model. So you can see all the images together here. You can change this one. On Google Colab, it might be a little bit laggy, but right now it also depends on the internet, also the server. So it might take a couple seconds to render. But
I'm gonna type error here.
what error do you get? You need to run all by sequence. If you skip some of the code block above, it might have issues.
I think our key talent might be kind of experienced.
Yeah.
We're going to working on this,
Yeah. Can you see this, all the data layers? Yeah, it's loading, but yeah, it's fine. You can try it later after the workshop, but basically showing the idea how to access the data layer individually, and also you can change the opacity. So on the right here, you see it's loading. After it's done, then you should see this one. So, and again, this imagery is pretty big, like a couple gigabytes, but we are basically rendering on the fly. So this is essentially watching movies on Netflix or YouTube. It's the same idea. You are just requesting the imagery. Depends on the zoom level. So you basically do the tidying automatically. And then if you really want to see, like for example, how it's being rendered. So if you go to Google Colab and then go to settings, not settings, Google Colab, and then I think it's under more tools, developer tools. And there should be one under called network. And you see here, when you zoom in and zoom out, you're going to get a bunch of thumbnails. If you can see it from here. So under the hood is like small tile. So when you put together, so this is how it's called HTTP range request. So basically, whatever you're getting seen from the map is being requested on the fly. So when you zoom in and zoom out, it's requesting the tiles. And this is, it looks like it's perfect, but it's actually a seamless imagery, but it's not. It's just a small thumbnail. If you see some of these from here, let me see. Yeah, for example here, right? You see 20, like basically they do the subdivide the imagery into smaller pieces, and different zoom level want to have different hiding scheme, right? If you open it up, it's it's not here.
I think there's like a preview tab, so you can go through each one.
Yeah.
I should show you.
Yeah, it's over on the right.
On the sidebar that's kind of collapsed.
Yeah. Okay, let me see. Let me post. Yeah, it's the screen a little bit too small. And then preview. Oh yeah. Okay, better. Yeah. So here you can see basically every tiles, right? Like this. So this is where it's being rendered on the fly. It's small tiles put together, and looks like seamless. And you can, like I said, you can change the color, you can change the value, you can change all kinds of things. So look at this one. It says color map equal to terrain. You can change it to whatever map public color map. So I can change it, for example, to jet. Okay, I can change this one to cool warm. Again, you can play with it. If it doesn't exist, you will throw the errors. But this is the nice thing that it's not predefined. It's like render based on your input, and it's the mid domain is going to render that for you. So again, it depends on how if the T-tiler server is overloaded. But let's see if we can see the result. Okay, hue shade. Yeah, this one right now is different, right? So different color. Earlier I used terrain, but right now it's red, green, blue, right? Different color, so we can change it dynamically. All right, so play with it. So this is how we access the data. And so the next, we're going to actually pull the also mosaic together, so we can compare the data side by side. Just run these two code blocks. And what it's doing is getting the data also mosaic from 2018, the other one from 2023. And then we're going to use the split panel. So this is earlier when you use the platform, you also have this split panel. And so now we're looking at the imagery on the left side is 2018. The imagery on the right is from 2023. And again, you can zoom in, you can move things around, you can compare, you can see the differences. I think I know there's some, for example here, right, on the left side, I'm not familiar with all the things happening on campus, but you can see in 2018 they have these buildings. Now it's like toned down, so probably going to have some new constructions on campus.
Student housing.
Student housing, yeah. Again, you can do this not just for D2F, you can actually use any imagery, any cloud optimized geotiff. So all you need to do is just whatever URL. So imagine you might have imagery on AWS or whatever. If it has a HTTP URL, we can just change it to here, and then all the source code will be pretty much the same. Okay, so for example, left and right, and then the split map, and then you can set the location to whatever the center of the location. So these are basically just some of the tools that makes it easy for you to visualize geospatial data on demand. Questions? So this is just to access the data from D2S. Again, this is not Google sending yet. It's not really cloud computing yet. It's just doing the data visualization. And starting from this, we're going to really get into Google Engine cloud computing. And we only have 40 minutes. We might not have time to finish all that, but like I said, we're going to go pretty quickly just to give you some flavor of what kind of things Google Engine can do. But you're welcome to digest it later. We're just going to run the code block and then step by step. So Google Engine has different data type, basically image collection, geometry, feature collection. So it corresponds to the traditional GIS vector data. So in imagery, if you run this code block in here, everything in Google Engine starts with EE something. So it's basically the API, and you can think about its so-called server-side object. So the imagery is stored on the server. We don't actually have direct access to the original data. It's already being rendered and then wrapped as an object. But we can ask it to see it. Basically, you can open like the box, see what's inside. So this is what this one is about. You're pointing to the imagery. So this is a global DM, for example. This imagery can be 10 gigabytes. It doesn't matter. It can be 100 gigabytes. It can be 1 terabyte. It's just a pointer, a reference to that data set. And if you just print out the object, and so here you can see, for example, what bands in there, what kind of property. So you can see all the metadata information of the imagery. And after that, we can do the visualization. So this is how Google Engine works, the cloud computing. Gmap, we create a map, we point into the image, and we tell Google Engine, oh, I want to visualize that using the minimum, maximum, and then using this color palette. And then I want to add the data layer to the map, and then just run it. So very much similar to use desktop GIS, right? You drag the imagery to the map, and then you change the symbology, minimum, maximum, the color map, and then you apply, same thing. But we're doing that using Google Engine. So take a look. Right now we have this imagery, and you can change the opacity. You can turn layer on and off. So this is the global DM, right? Again, this can be several gigabytes, but we right now we are rendering on the fly, and it's pretty fast. What you can do here, like I said, the palette here, you can change it to anything, like any map, probably color map. I can remove this one and change it to terrain. You can run again. It should change it right away. So we are pulling the data from the cloud server, and you can render it. For example, I change it to cool warm. See how fast it is. So you're pulling the data on the fly, and it's really responsive. Again, the data can be several terabytes. It doesn't matter. It's fast. And the reason is the data being rendered based on my zoom level and also the map area. So if you zoom in, you're going to have high resolution, but your area is pretty small. So overall, the data set that you need is pretty tiny. And all the data coming, so every piece, if the internet is very slow, you will see it's popping up square by square. It's basically every tile come from a different server and then put it all together. So this is raster data, but Google Engine also has vector data called feature collection. And there's a function called Gmap GeoJSON to EE, right? So earlier we have the Purdue project boundary. That one is just a regular GeoJSON. So we can convert this one to Google Engine object. And I want you to keep in mind, everything in Google Engine is called server-side object. It's not client-side object. So it is, if client-side, you cannot actually interact with each other. So everything needs to be put in the server. So they become, basically, you need to speak the same language. So in the server side, it's optimized so they can interact with each other. Your local one, you cannot. So that's why we use the GeoJSON to EE to convert the local GeoJSON object to the cloud, and then you can do some interaction. So if you run this one, and then you can add the layer. So the M.8 layer, that one can add imagery, can add vector data, it can add all kind of data. So now you see, right? So we are adding this GeoJSON, the Purdue campus, to the map. And under the hood is the global DM. You can see the color is not very good because when you compare to the global elevation ranges, the campus is pretty much very flat. So this is just to try to show you like you can deal with different data layer. And so here we can use the e.train.Qiusheng. So this is a global DM. We can use this function to create a Qiusheng, and then we encrypt that to the Purdue campus, and then we add that to the map. So take a look and see this one. So this is the DM, 30-meter DM for Purdue, and compare this one earlier to the high resolution one, right? You can clearly see the differences. And this one is not very good, right? It's very close resolution. You don't really see the details. If you want, you can add the data layer together. So if you go back above, you can grab those two links. For example, the Qiusheng and also the DTM URL. You can actually put them all together. So, for example, I can come back to here and right. So now I'm adding the Qiusheng, and you can compare different data layers. So this one is the global one. Oh, the Qiusheng, I might need to change the name. Are they using the same name? It's RTM, DTM. Oh, this one, sorry. It should be, I should also add this one. Again, don't worry, you don't need to try it right now. I'm just showing you the differences here. Right. So you can see the differences. This is the global one. This is the one from D2S. Right. It's huge, the differences. So this is how you pull the data from Google Sensing and also data from multiple sources. They can all be put on the same map. And so the next one is about image collection. So image and then feature collection. Basically, one feature collection is equal to one shape file, one GeoJSON, something like that. But Google Sensing also has the other one called image collection. And we are pointing to the entire Sentinel-2 image collection. So this is a huge data set. Basically, all the imagery acquired by Sentinel-2 is inside this image collection. So this one has tens of millions of images. So we're just creating a variable pointing to this image collection. And then you can do all kind of filtering. So for example, you can filter by date. Basically what we're doing here, okay, I only want imagery from 2013 to August 2024. And I want imagery with cloud coverage less than 5%. And this is the power of using Google Sensing. It doesn't matter how many images you get. I can ask you, okay, just create a median imagery. Basically, take all the images all together and then just take the median value for each location and then click to the area that you want and take a look. So now we have this Sentinel-2 imagery. And under the hood, this is a local imagery. So if you want to see how many inside, can you use collection.size. It might be a lot. So the reason for this one is pretty fast because every pixel that you're seeing from here, it comes from a different date. So this looks like a seamless imagery, but it's not. Like I said, every pixel is basically taking the median value. So imagine, for example, for each location, maybe you have 100 images taken with cloud coverage less than 5%. And for every imagery, you have a different band. So for each band, it's taking that 100 imagery of that particular band, take the median. So the reason we take median because it's not too bright, it's not too high, not too low. Because it's too low, it's very dark. It's too bright, usually it's cloud. So take the median, it usually looks like this. And this is very much similar to when you use Google Earth. And then you zoom into Google Earth, every image looks perfect, no cloud. Those images is most likely have been processed using Google Sensing. And it's remove the cloud because you're taking the median pixel or something like that. So see this one. How many images in here? 1,200,000 and something like imagery. But this so 1 million is all the imagery around the entire globe. So for the entire image collection, there are 1.2 million images meet this criteria with cloud coverage less than 5% or acquired from January 2023 up to right now, for example, April. So there are 1.2 million images. Think about that. It's huge. And then we are taking the median pixel and then clip the imagery. If you really want to try it out, you can remove this one, saying that I don't want to clip it. I just remove it. This will create a global mosaic. So if you run it again, it gives you the imagery for the entire globe. So right now we are visualizing the result of 1.2 million images processed and see how fast it is. Seconds. So you can zoom out to any location. Right? So it's streaming the data on the fly and it's doing the processing. So it's running the computation on the fly. And If you're trying to process 1.2 images on your local computer, good luck. It's going to take you how long to download the data, and even if you can store the data, you won't be able to process it because the computing power is huge. But right now, we're basically requesting on the fly. So when we zoom out, this is coarse resolution. It's going to resample all the data and then put all the things together. So again, every pixel comes from a different imagery. Every pixel comes from a different date. And this is kind of like when you use Google Earth, right? You zoom out and all the images look perfect, no cloud. It's all fake actually, because it's doing the processing and then render the data on the fly, because at any time during the day, the entire globe is covered by 60 to 70% cloud. So actually a ton of data. And here you can change it to any time period, as long as your data have, for example, you might, so the data availability from 2018, 17 to 2024, you can change it to other day if you want to play with it. But again, you need to be careful. Sometimes if you're dealing with too much data, it might not load immediately. But this is the power of using the cloud computing, is that the location doesn't matter, the time doesn't matter. As long as you have global coverage, you can do it for anywhere. So next time, if you're looking for, okay, I need to do something for this area, I need some imagery. In the past, you probably go to NASA, go to ESA, trying to use the web interface, trying to do the search and then download the data. This one, couple lines ago, you can see the imagery for any location on the globe without having to download anything. So 1.2 million images, it's probably going to take you, for each imagery, I think it's like how many gigabytes? Each Sentinel-2, like 2 gigabytes. Multiply 1.2 million, like I don't know how many terabytes. It's big, but you can zoom in, you can zoom out, and you can actually change things dynamically. You can change the visualization. You can change different band. For example, I want B854. You can change it. It's being rendered on the fly. So this is about vector raster data, but you can also do vector data. So Google Sensing has a lot of vector data. So this one specifically, we are rendering using the sensors raw data. And so you can think about everything on Google Sensing has a unique ID, kind of like our social security number. So basically what we're doing is, okay, pointing to this data set, and then, okay, I want to do some filtering. I want to select certain date. I want to select only within certain area. You can ask it to do it, and then it's going to render the result back as basically just like a Thai URL. Exactly the same as Google Map and Google Earth. It has tons of data, and it's really fast. And you can, for example, right now we are basically just rendering, getting the data for the census raw data for Purdue campus. But if you want for something else, you can change it, or I can render the entire US. So this vector data set is probably a couple hundred gigabytes, and you see how fast it is. So this is vector data set. So in terms of visualization, it's pretty fast. So right now we are not using the D2S. We're using the Google server. It's much faster. So because they have much more powerful data. And you can change the visualization. Again, we don't have time to go into all the details. So everything is just a server-side object, and they have so-called filter. So this is pretty much similar to desktop GIS. You can select by location. You can select by attribute. You do need to learn basically the API. So I recommend that if you're really into it, you can just go to the, for example here, the Google Sensing documentation. And so everything basically you can think about is just Python functions, coding the building blocks. So if you go to the documentation and then the references, on the left side here you see the client libraries, and these are all the Google Sensing so-called the objects. So for example, you can think about image feature collection. So this is all the things you can do with vector data, and you can see here I can filter bounds. I can, for example, filter by the date. So everything is just like building blocks. You can apply things to it, and then you can do something. So for example, here we're getting this country boundary, and then we're just going to filter the data, select the US boundaries. So Google Sensing has a huge data catalog. I think right now it has almost 100 petabyte. 100 petabyte. So one petabyte is 1,000 terabyte. So if you want, you can go to the website data catalog in here. You can search all kind of data. So most of the popular one is pretty much all there. So for example, all the Sentinel data set, Sentinel-2, for example, and reflectance top of atmosphere. And you can basically step by step is a hierarchy. And after that, we can have access to all the data. So this is kind of the analysis, just like you Netflix open the entire movie database for free. You can watch any movie you like. You can search it, you can try the name and then pointing to the ID, then you can visualize that. So this is about the vector data. We can continue to do the filtering. You can add different hierarchy, right? So right now for this one, we are visualizing the state boundary. So earlier the one is the country boundary. Right now we're using the state boundary. So this one is basically the label 1. Here is the label 0. So it basically is a strapper. You can load any strapper also from your local computer. And you can visualize that. Again, just try it out. You can play with all kind of visualization. So here, you can also change the color. So for example, you can change. This is kind of something that's sometimes very confusing for beginners, because in desktop GIS, you load the data, you double click, and then you can change the visualization. In Google Sensing, you do need to know the coding to change the color. But if you don't know how to do that, it's also pretty simple. Let me show you here, right? I can search the data on Google Sensing, and it just create a map pointing to the data, and then you can just add layer, and then add there, okay, and then countries, TRIES, and then so this one is usually like what color palette, how do you want to visualize that? If you don't know what to provide, that's fine, don't do it. And then so this will be the layer name. So for example, countries. And by default, it's just going to add like something like this, right? So it's the default color. And then you can upper right corner here, right? Turning this layer and then click this button. This is where you can customize. So this is similar to desktop GIS. For example, I'm going to change the color, outline color to red and apply. See, now it's red, and I don't want to fill the color. You can change the opacity to 0. See, so this is what Geemap is about. Is have those widgets that allow you to change the visualization dynamically, and I can also change the fill color, for example, to blue. Right. So what we are doing here, this couple of lines of code, is to simulate what you do, like using an interface. But you do need to get familiar with the syntax. Okay, so this is about the visualization, and the next one is about searching the data. What you need to simply create a map, create a simple map, and then upper left corner here, and then click the data. Here you can search any data. So this is kind of like you go to YouTube, you search the movie or whatever you like, right? So here you can just search maybe elevation. And you see, these are all the data set elevation contained within the database. And you can select whatever data you like. For example, I want the HRTM, this global data set. So the most important thing is this one. Get this unique ID. So whether it's an image or it's an image collection, it's a feature collection. And this is the one you're pointing to the data. And you can click this import button. And so here it's going to show you the examples, the sample code for this data set. And then you can just press Ctrl C. And so from here, I can just paste the source code to this one. The only thing right now is, so we just do some recent updates. So right now it's using this uppercase, but I can change to lowercase so they to be consistent. So when you name the variable, you can use uppercase or lowercase, and then just run it. So see, so now we are loading the DM and we're calculating the slope. And you can search any data set. So basically, they are 100 petabyte. You search it, see what data you like, you visualize it all at once. So kind of like you can watch any movie for free. All the movie produced by mankind, you just watch it. You don't have to download anything.
And that's all available through the Google. Right?
Yes, it's all in the Google Sensing data catalog. So you can go here to search any data you like. It's huge. All the SETA imagery, vector data, raster data is pretty much all there. So that button can help you search any data set you like. And you can, for example, I want some lane cover. Just search it. It's going to show you all the lane cover data available. And then you can just, for example, maybe USDA crop lane data layer. You can click the import button, and oops, after you click, maybe you need to hide this one. So for example, lane cover. Okay, and let's say I want the USD, for example, maybe this one. Click import, and here is going to show you the source code. Right, so the sample source code, I can just simply copy, and then come here, paste into your code block. Again, right now you need to change this one to lowercase if you're using lowercase, but in the next release I'm going to update it. See, right now you have to enter this. So you don't need to download anything. You can stream the data on the fly. You can change the color. You can change all kind of things. And every data set can be gigabyte. It doesn't matter. It's going to load it very, very quickly. And so this is SRTM. I can also visualize something like this. Again, play with it so you can clip the data. So it's not just for visualization. The power is that you can have reference to data. You can do something on that data set. So you can think about it. Everything is just every individual person, right, in the data catalog. And you can say, okay, I want you to do something, and the server is going to basically apply things to that certain data set. So that's about searching the data. And next, let's quickly go through some of the tools you can utilize. So just run this code block, and it's going to load some data layers, so some DEM, some vector data, and also some multispectral data, right? So these are all available at the global scale. And so geemap allows you to interact with the data. So all you need is just click your mouse on the map, and on the right here, so when you click your mouse on the map, it's going to get your coordinates and grab all the value, for example, all the pixels intersecting with this coordinates, or all the polygons intersecting with this one. So this is called inspector. It's very much similar to ArcGIS, QGIS, right? The identifier. You click on the map, it's going to grab the pixel value, and if there's some, depends on internet, right? If there's no internet, this is not going to work. All the data is in the cloud, so basically getting the data on the fly, getting all the pixel value, and then display on the map. So you can see here we have pixels, right? Every pixel, different spectral band. You have the DM elevation value and also the vector data, right? So right now, if I'm clicking on California, right? So you can see we get the pixel values for this one and also the feature data for this particular boundary. So the inspector is something from here. We use the map.add inspector, but I can comment it out. I can just add all the data layer, and then you can use the toolbar. So the toolbar is in here, upper right corner here. If you click the button, it's this first icon. So this is one is going to turn on the inspector, so you can run on it. So this is the inspector. You can also do the plotting. So the plotting is that allows you to create plots, right? So right now we have this Landsat global dataset. We also have some hyperspectral data here, Hyperion. And so this one is going to add this like two data layer. So if you click your mouse on the map, it should add the spectral signature, right? Click anywhere, it's updated automatically. So if you click on the water, it should look different. Right, so this is the remote sensing spectral signature. You can switch to Hyperion, so this one is hyperspectral. And I can run this one again. You should see it different. So basically this one has 200 bands. So you can get all the pixel values and then you're going to have something like this. You're welcome to, for example, to try out, so you can change the options, right? So if you run this too, and then if you click again, it should look different. So everything on the map is like kind of like widget. You can change it dynamically. So this is about getting the spectral signature, and you can do like color map, color bar. So for this one, we are adding, for example, the global land cover dataset produced by European Space Agency, right? So this is an image collection, and the first imagery in the collection is the land cover map. And this is how we're going to visualize that. We add all kind of data layer. We also add a legend and then center the map around the US. So look at this. And you can turn the layer on off. And you can zoom in, right? So this is the land cover from 2021. Again, you can compare it with the satellite imagery beneath. See if it makes sense or not. So this is the global land cover dataset from European Space Agency. So on the right here, this is the legend, basically the lane cover type corresponding to the color of the data set. And I can skip this one. So for this code block, we just use this called built-in legend. So basically, Gmail already have those built-in, but you can change the customization. So if you need to add a legend that you want to change the name, change the color, everything is customizable. So everything added on the map is a widget that allows you to change things if you want to. You can also add a color bar. So the color bar is, for example, the DM, and you can, similar to what we did earlier for the D2S, you just one line of code, add a color bar, and look at this, right? So right now we are getting the DM using the vector data to keep this global DM into the US boundary, and then I can add a color bar just to here to the lower right corner. And you can change the color bar to vertical one, for example. You see, I switch to vertical. I can also make it transparent. So we go back, oops. Yeah, the transparent is not working. It's weird. It should. There might be a bug. Yeah, sometimes some of the packages, if they update it, because we depend on some of the packages, so sometimes things might not work as expected, but you can do it vertically, and you can do split map. So this is similar to what we did earlier. And take a look at this one. It's just one line of code, and you can pass in base map layer. So right now we're just passing a string. This string is from the base map layer, so I can change it to something else if you want to. For example, Esri.war imagery, for example. It should be really quick. So you can basically create a split map side by side and use the base map, but you can also provide custom data layer. So this one is using the Google Sensing data layer, right? So we have two lane cover data set, global from 2000 and 2021, and you can actually get the tile layer and then just use this add split map function to do that, and then we add a color map on the right. So this is just, for example, just 1 year difference. I'm not sure you can see. Let me split it to see the differences. A lower left corner here, there's also a label, right? Lane cover 2000, lane cover 2021. Again, we don't download anything. We just stream the data on the fly. And this data set itself is many gigabytes. So, and we're creating the data on the fly, so you can clearly see the changes. You can do some analysis if you want to. So that's about loading some, use some visualization. And you can also use the time series or time slider. So we only have 10 minutes, but we're going to quickly go through this one. So Google Sensing is particularly powerful doing like time series analysis. So for the lane cover dataset, for the NFCD National Lane Cover dataset, we have imagery from 2001. I think the latest one is 2021. So you can actually put all the data, just one line of code. You can pass in the entire image collection and then use this time series inspector to load the data. So for example, I'm zooming to Las Vegas, right? So on the left side is 2001, on the right side is 2019. You can see the changes before and after, right? And you can also change the different data layer, right? I can change it to 2011. It's updated automatically. So basically, Gmap can help you visualize those time series data very easily. And you can also do, for example, let's look at this one. So this one we are looking at the Purdue campus, right? So you can see the imagery. This is the USDA NAM imagery, 1 meter resolution. So we have imagery from 2008 all the way to 2022. And you can also see the differences in here. So we're using the boundary from the D2S project boundary. And take a look at this. Was 2002. So that new construction probably is just started maybe a year ago. So 2022 is not there yet, but you can see like this portion, it used to have those buildings, but it's not anymore. See? And this is high resolution, it's all free. So the USDA NAM imagery cover the entire US. So we have national coverage every 2 to 3 years. And everything is on the cloud server. So you can actually, you can change this one to whatever area that you want, and then you can just pull the data. So if you need to work on a project, if you need some satellite imagery, use Google Sensing to quickly grab the data and then do some simple visualization. So this is about the inspector, but we can also have the so-called the time slider. So this one is going to add a slider to the lower right corner here. And so this is the NDVI global coverage. And you can slide through to see the differences. So this is daily imagery for the entire month. So you can just change it. So this one is nice if you have like you have 100 time periods. You want to see them all at once. The time slider allows you to slide through. Rather than adding 100 data layer all at once to the map, you're just adding the particular data layer for a selected time period, and you can change it. You can also click the play button, but it's going to be a little bit laggy because it's pulling the data on the fly from the server. It might take a second or two to display. And this one may not work very well on Google Colab because it's using multi-threading to get it. And you can do weather data, you can do others, so we don't really have time to get into the detail, but you can try out the other two examples. So this is, as you can see, it's very powerful visualization. But the real power is actually doing analytics. So it's not just for visualization. So here I'm going to show you a simple example. Like we can think about here, I get the DM, global DM, and I also have the boundary for the US. Right? So right now, if I ask a simple question, which US state has the highest mean elevation? Colorado, right? Pretty obvious, right? See the white color here. But if I ask the opposite, which US state has the lowest mean elevation?
Delaware.
Delaware? Right? It's hard to tell, right? It's all around this corner. And this is where you can actually use Google Analytics to do that. Just one line of code, doing a zonal statistics. So on the zonal statistics, it basically give you a boundary and then want to calculate all the statistics within that boundary, right? So we can take a look. So it's taking the global DM and it's using the US, and it should take you a second or two to calculate zonal statistics within its polygon. And then we can just turn this one into a data frame. Now we can take a look, right? So sort the value from mean, and so it's this one here, mean elevation. Who's the Delaware? Right? Good. Right, Virgin Island. And who is the top three, for example? I can probably do solve value to the reverse. VRSE RE VRS equal to false. No, there should be a whatever. Let me remove this one. I can display all of them. Oh, not the head, just the entire data frame. Right, so for the top three, Colorado, Wyoming, Utah. So we go back to the imagery in here. So this column, look at this column on the left side, the mean. So basically it takes the mean value, all the pixels within each polygon. And if you need to run this one using desktop GIS, this might take you some time because the imagery is huge. And this is so fast because it's like doing all the things using tens of thousands of servers to do the aggregation. And you can do it for multiple multispectral. So for example, I can also do, or you can create a bar chart in here. Just one line of code, you can actually look into this one, like for all the states, the zonal statistics. You can zoom in, you can take a look the data, and I can reset it, right? So here, Delaware, Virgin Island, and then Florida, and the top three. So you can basically run analytics and then get the visualized result pretty easily. You can also do multispectral bands. So if you are looking at Landsat data, you also do some zonal statistics. Run it, you see, within seconds, you get all the bands. So basically every state, the mean pixel values within each polygon. And you can also do zonal statistics by group. So for example, one user case would be, let's say you are working for the USDA, for example, right? And right now you're trying to figure out, let's say, which US state has the largest agricultural area? So agriculture here, look at this one. So it's which color? Cropland, for example, 40, right? So if you overlay on the map, right, which one has this kind of pink color, right? Right? It's kind of somewhere around here, but it's hard to tell because the size is going to be different. And this is some simple question, like if I just want to get a rough idea, you need some accurate number. You're not just guessing. So in GMap, it's just one line of code, zonal statistics by group, and you can get the result pretty easy. So you can do it for the NFCD. I can do it for NFCD is just particularly for the US, right? So again, this one, this brown color here, this is the cropland. So we can just run this single function. Give me the lane cover data, this is the imagery. Give me the vector data, this is the boundary. And then say just run the zonal statistics by group. So because each state going to have a different composition, right? So for example, here you have cropland, you have forest, you have urban, and this might take a couple seconds, so it depends on how big is the data set, but this is certainly going to be a whole lot faster than you're running using desktop, because you need to have access to the original data and it run a while. This usually takes a couple seconds, so you can run things at scale. It doesn't matter if it's the US or the entire globe, you see, within seconds. Now we get the CSV, and you can just turn the CSV into a data frame. So now you can take a look at, for example, the lane cover, the cropland is number 82. So you be this column. Look at this one. And you can just rank the column. You can figure out which one is the highest cropland. You can also do it by percentage. So if the other question I'm asking here would be, right now I'm not talking about the absolute cropland. I'm talking about the cropland area divided by the state area. So which US state has the largest percentage of agriculture compared to its state area? Now it's relative, right? It's not absolute, right? Because you may have a large agriculture, but if your state is much larger, you may divide it. This is more like population density, agricultural density, whatever. You can run the same statistics, and all we need to do is just change this one to percentage, then we get the percentage. Okay, so there are a lot of things you can do. This is just one simple example how you can run the statistics very, very easily. And we only have 5 minutes left. So the last one, this one is more fun. It's like creating animations. So you have access to tons of imagery, time series images. So you can create animation pretty easy just with a couple lines of code. So let me show you this one here. For example, I can create a map and then you can show the base map imagery. You can simply draw a rectangle anywhere around the globe. So I can, for example, I can zoom to maybe, how about this area, for example. Let's say, okay, right now I'm doing something. I want to see the changes of this certain area. I can just simply draw a rectangle somewhere. Don't make it too big because the computation might be huge. So you're looking at this area and then just run this code block. And then after that, just let it do the work. So this simple line of code is going to access to the entire Landsat data catalog for over 40 years. And so we're going to do all the cloud removal, mosaicing, and then just get you a nice imagery every year. And then putting it all together as a simple animation. So this usually takes 20 or 30 seconds, but you can try it out. You can do it for anywhere around the globe. It doesn't matter. So, see? And this is taking 40, 50 years of data. And it's this graph rate. You can see how the changes of the river dynamics. And think about how long did it take you if you, without using this cloud computing, right? So the entire data archive. So let's say, for example, every 2 weeks, right, you get one imagery for any location. Every year you may get 24 imagery for every location. You might have cloud, you might have no cloud, and then you have 50 years. Think of how many images you need to process. And this can do anywhere around the globe. You can do it by year, you can do it by month, by quarter, whatever time period that you support it. And you can change it to something else, right? You can define, so if you know like the location, the bounding box, lower left corner, upper right corner, all you need is just change this bounding box here, and then just one line of code. So you can do it for anywhere around the globe. You can also specify the start and the end date, so it can be anything. You can also specify, okay, I just want the imagery for the summer. So if you're working on agriculture, I only want the imagery for from June to August or something like that. And usually 20, 30 seconds, like I said, it's a lot of data led to data processing. And still reduce, see this one, right? This is Hong Kong. See the changes, the new construction of the airport. And again, you can change it to anywhere you like. I can do Las Vegas, you can do whatever city you like. Sometimes you might run out of memory if your area is too big, because it's processing tons of data for 40, 50 years. And then take a snapshot, remove it in the cloud, and easy and fun. So try to customize to whatever area that you like. And it doesn't have to be Landsat. It can be Sentinel. It can be any image collection. It can be any time series. It can be lane imagery. It can be anything else. Right? Look at this. Last figures. So you can see the fast growing by year. Again, you can do it by quarter, by month, by week, by date, by minutes, by seconds. If your imagery support that, you can do that. So Sentinel-2, I'm going to skip that. You can do MODIS, right? So if you're interested in, for example, I'm going to look at imagery at a continental scale. I want to see the changes of the vegetation in this particular area. You can just call this function and then give the output and then just say, okay, I want the terrestrial satellite. I want this NDVI band from 2000 to 2022, and then every frame per second. See this, right? How nice it is! This is like the nature is changing. So this you can see the phenology changes. Again, you can customize it. So this is, for example, aggregating data from 20, 30 years. And the last couple of examples, this is using the NOAA GO satellite. So this one is very high temporal frequency. So every 5 minutes you get one imagery. So this is used for weather and climate. So you can, for example, capture anything happen at a large scale. And you might have seen this one on the internet. This is the famous Tonga volcanic eruptions. Every 5 minutes it has imagery, so you can actually get the imagery and then just process them, right? So next time if you see some of this on the internet, on social media, you know, okay, I can create this one. I just need to know what imagery, what satellite was being used, and all need to figure out what's the time when it happened, what's the area, and then you just change the coordinates. Then you can have something like this. So think about here, not really complicated, right? Figure out the start and day, what satellite you want to use, and if they have some additional parameter, you can customize it. And then just one line of code. So it can be volcanic eruptions. It can be weather and climate. So all you need is just change the bounding box. That's it, 20, 30 seconds. Then you can create this kind of animation. Again, this is a lot of data, many gigabytes. But using the cloud computing is super fast. And it doesn't matter the location, doesn't matter the time. It doesn't matter how big is the area. The area sometimes matters, right? The more data you have, the longer time it's going to get. So this one shows you, for example, hurricane, right? It can be anywhere. So next time if you see on TV, like showing something like this, you know how to create it because there are tons of satellites. And it's all available on Google Sensing. So after, I think, 10, 20 minutes, the data is being ingested from NASA to Google Sensing. And then you can access to the latest one on the fly. And the last example to show here, we are running out of time, is the wildfire, for example. You can, because these things happen at like very large scale, it can be captured. As long as something can be captured by the satellite, and if the satellite data is available on Google Sensing, you can use it to create a visualization, and you can run all kind of analysis. So for today, we're mostly focusing on the visualization, but the real power is actually doing analytics. So you can run things like on the fly. For example, this is a Wi-Fi happening, right? And you can also delineate the boundary on the fly. And you might have seen this sometime on Google Map. If you search the location, if there's Wi-Fi, they will probably show you the evolution of the Wi-Fi. So you can basically combine visualization and analytics together. And the last one here is I want to show here, create a map and then just add the time-lapse GUI. And for this one, I can do it for anywhere. So you don't even need to do coding. So I just, there's 3 lines of code, create this one. Now I can zoom to anywhere that I like. For example, I'm going to see, for example, here, Las Vegas, right? So zoom to anywhere you like. Simply draw a rectangle. And after that, I can just, I can also extract the water basically. So for example, I can do the water index and just wait for 20, 30 seconds. Let me see here. It may take some time, but you will get the animation for the satellite data, but you can also do some simple vegetation water index if you want to, and try it out for your own hometown, whatever area that you like. And 20, 30 seconds, you will be able to get animation. And then you can download it as a GF animation or MP4, whatever you like. So under the hood is getting all the data for 40, 50 years, and then just do the analysis to do aggregation by year. You can also do it in here. You can change the band combination. Like there was said that there you have different band combination, and you can also do this one right now by default using this by year, but you can do that You see this one? So I'm showing here, I extract the water, right? Because I select the water index. So let me remove this bounding box. And under the hood, see this one? Pretty cool, right? And I extract the water. I didn't do anything. Right? 20-30 seconds. You can run all kind of analysis. You can see how it's changing year by year. So now you see the real power of like not just prevision. It doesn't matter how big is your data set, how big is the area. I can easily doing something like this. So again, we didn't have time to get into every details. Like I said, we went pretty fast, but I want to expose to you like what kind of things you can do. Then you can look at the code example, change the coordinates, change the time, change the data set, and then you can just, now you can go online to watch any movie you like. So basically now Netflix is free, sign up an account and then try it if you like it. So there are tons of data set, tons of applications, environmental, urban, disaster management. So you have all the imagery ranging from Landsat 30 meter resolution to aerial imagery 1 meter resolution, DEM, vector, all kinds of data sets. So it's all accessible through Google Engine, and GMap can help you visualize the data very easily, and then you can do whatever computation you want. Okay, so yeah, we are over time 6 minutes, but if you have any questions, we'll be here the whole conference, so feel free to talk with us.
Thank you.
You're welcome. Yeah.
Hope you guys enjoyed the content.
Yeah.
Like the Qiusheng mentioned, the group working is global.